Thank you for joining the Solar Valley Annual Conference 2025. My name is Ron Loveridge. I co-chair the Solar Valley Consortium along with Alfredo Martinez Morales. By way of background, I'm a longtime political science professor at UCR. Also, I was mayor of Riverside for 19 years and 14 years as a council member. During that time, I was a 25-year member of the SCAG Regional Council, 20 years with the South Coast District Board, and 8 years with the California Resources Board. Solar Valley Consortium is in UCR's College of Engineering Center for Environmental Research and Technology. CCERT is UCR's largest research center. The first 100 days of the Trump administration certainly make the future of solar energy and storage uncertain. Information today will be immensely helpful for steps forward. Editorial comment, we need to figure out how to build energy, solar energy and storage rather than to oppose or overregulate. Kudos to our executive director, Fred Schwartz, for his outstanding preparation in organizing this 2025 conference. Godspeed, Fred. Take it away.
Thanks very much, Ron. Really looking forward to this event. I would really like to thank both you and Alfredo for co-chairing and guiding the consortium and its activities. I would also really like to thank Ed Smeloff for assisting as well in guiding the consortium and its activities. And again, I would really like to thank Sarah Salzgiver, without whom this would not be occurring. So to set this in context, in a paper published a few years ago by the CEC, the California Energy Commission, indicated that we need roughly 7 gigawatts annually of storage for 25 years to meet the state's clean energy goals. This is roughly 3 to 4 times what we've done in the best year so far, and indicating that this is going to be a really heavy lift. So we're really pleased, very happy to have with us as the keynote speaker, Siva Gunda, Vice Chair of the California Energy Commission, to deliver the keynote speech this morning. Appointed originally by Governor Newsom to the California Energy Commission in February 2021, Siva has since been a guiding light for the commission and its activities. Previous degrees in aeronautical and mechanical engineering provided a good foundation for his understanding of the electrical grid. Since obtaining the degrees, he has focused on public policy, where he has collaborated extremely effectively with California agencies such as the CPUC and the ISO, as well as with industry, academia, and the public. So please welcome Siva Gunda.
Thank you so much, Fred. Thanks for the warm welcome. And I see the agenda, an excellent agenda for today, and all the speakers, and just what a fabulous group you've been able to pull together, and many of whom I consider mentors and advisors as I've been working in this area for the last 5 years. So I would like to take the cue from you, Fred, and just set the stage at a top level on what are some of the climate ambitions, how are we kind of planning for that? And hopefully that gives a good context for the rest of the day. And I also just want to have a warm welcome for all the participants, and thank you for having me here. So I'm going to share my screen just in a moment here. Okay, so just a way of introduction, currently have the privilege of being a part of the Energy Commission as one of the 5 commissioners. And I've been in this role for the last 4.5 years, during which I've broadly focused on electric grid planning and reliability. So I'm going to try and use some of those lessons learned to kind of share where we are. To start off, the Energy Commission, for those of you who might not track every day, I think we broadly have 4 functions. The Energy Commission is kind of the state's planning agency, planning and policy. So much of the implementation work happens at the PUC and CAISO, begins with some of the planning work that the CEC does, such as the demand forecast. The CEC also has an important role around being the state's data repository and making it accessible. So I think of it as like the EIA for the state. We also have a very large function of being the clean energy investment vehicle for the states, whether it's R&D or D&D money. And finally, we do have some regulatory functions such as permitting, building codes and standards, and more recently, looking at the oil and gas sector. So, we all know this, but one of the things that Fred kind of provided some guidance on is to just kind of set the context on how important energy policy is. It touches most of the things that we all care about in some shape or form. Energy policy is climate policy, right? I mean, so much of climate agenda is dependent on how we evolve the energy policy. It's also the environmental policy, how we build, where we build, and kind of the tension between clean energy and our conservation goals. It's directly impacts economy. The more access you have to energy, cheaper energy, there's a direct correlation of economies growing with that. And finally, and one of the most important thing oftentimes that is kind of left to the end, is the social justice element. So much of what we do moving forward has to both overcome the historical precedents of energy planning, but also kind of accelerate, the positive momentum along those lines. And again, I see former Assembly Member Garcia here, who has been a champion for much of this work. And just kind of like leaving, before I move forward on this, just want to note that the climate change that most of our models predicted, and even in 2010s, when I was at UC Davis, what we're seeing today was not expected until 2040s. The weather, the climate is just changing rapidly, and as we work on the energy policy, we're also fighting climate change, and it's a lot of stuff together, and we need to be mindful of that. As we think about 30,000 foot level, most of you know this, but it's good to remind ourselves when we think about planning for the state, it really starts with the California Air Resources Board and the scoping plan. So the scoping plan kind of lays out a blueprint, and the latest scoping plan essentially calls for large swaths of economy being electrified, and then supporting the rest of it through clean molecules. And then, as you think about electrification as an important element, both on the end use side, but also building the necessary gigawatts to support that, that's where the Energy Commission comes in. We kind of think through what we call the SB 100, which is our plan to meet the electric load, 100% of retail sales of electric load in 2045 with zero carbon resources. And that's something that we are working. And as you go down then with the Public Utilities Commission and other local regional authorities such as LADWP and others, they're all then looking at, how am I going to take this and then actually implement boots on the ground. And also, one of the most important pieces we think about here is, as we move towards electrification, how are we going to manage the decline of fossil fuels? So this is just, the complexity, but also important for those of you who are in the planning and then kind of thinking about implementing it. So 30,000 foot level, when we think about the California electricity planning, again, I'm going to speak about specifically CAISO, PUC, and the Energy Commission, but this applies, the kind of the infrastructure, the structure applies for most of it. And I thought this would be helpful as you go into the rest of the presentations today and transmission planning and such. So 30,000 foot level, we start with CARB, scoping plan. What the Energy Commission does is provides demand forecasting and policy recommendations into the scoping plan. And as I mentioned before, the SB 100, which is the clean electricity grid kind of goals, kind of go into scoping plan as well. And then you kind of take all of that, once you understand the demand and once you understand the GHG constraints for a specific year, you then flow those constraints into the integrated resource planning at different LRAs, CPUC being the largest. So those kind of IRPs or integrated resource plans tells us, directionally what our procurement strategy is moving forward. And then that has to go into CAISO and other balancing area functions to think about, how are they planning for transmission. So that's the overall structure as we go through, and each one of those things have to evolve as we move forward. We've made some good progress since 2020, especially the reason I mentioned 2020 is the last time we had rolling outages in California, which was pretty big, the August 14th and 15th, and a lot of risks in this evolving grid has shown up, and then we did a lot of work to remedy them, but we have a lot more to do. So on the SB 100, again, just wanted to provide the 30,000 foot level takeaway from that. So the 30,000 foot level takeaway is we need to build an enormous amount of gigawatts as we move forward. And I want to note a couple pieces on the slide. This is from 2021. The 2025 report is still being developed. But as you see there, in 2021, we were looking already at adding another 150 gigs. And now, based on the latest work, the draft results are still being prepared. Because of more electric grid load than we anticipated, because of data centers and because of potential hydrogen economy, which was not included in 2021, we could see upward of 200 gigawatts of new build that we would require. And that is an enormous amount of kind of infrastructure that we need to build, all the way from generation capacity to transmission to distribution and so on. So let me kind of take a moment here to just put in context of the opportunity we have. Yes, these numbers are big. It could kind of definitely be scary, but also it's the opportunity, right? When we think about the electric grid, the transmission investment, the distribution investment, and talk about transportation electrification, the charging infrastructure, just kind of the ability to decarbonize buildings, when you put all of them together and hydrogen, we're looking at about $500 billion of investment in California over the next 20 years. That's a significant market opportunity for us to kind of really unleash the power market, through optimizing the regulations to create the conditions for, the private sector to thrive, but also ensure that the equity of the transition is structured well. So again, a big part of the story here is how much more solar we need. Solar plays two important roles, right? Based on its load profile, it provides you a lot of energy in the middle of the day, a generation profile, but also it's required for charging a critical part of the grid progress, which is storage. So you would need a lot of solar energy to be able to charge the storage to be ready for those evening times. As the solar goes down, before the wind comes out, you need some sort of a firm power. So to Fred's point, as we think about building a lot of these megawatts, we have been doing pretty well. There is a reason for optimism that we are building fast. The last couple of years, both 23 and 24, we have built over 6,000 megawatts each year. Last year was a record year. 2023 was a record at that time. So we're continuing to build well. But as we do this, we still have to contend with a lot of different pieces, right? The tariffs, potentially, global dynamics. We have to think about interconnection queue. I'm sure we'll hear about that today in the panels. How do we continue to evolve our processes to ensure that the land use development and the generation development happens in time and gets interconnected to the transmission grid and serves the customers, right? And that's where you have the opportunity, for example, with the community solar and storage. So you have these opportunities, and I really like the last kind of discussion you're going to have today around having all options open. I kind of think of this as turning a bend And as you turn a bend, it's better to have a broader freeway than have a narrower one. So to me, it's like looking at all the options and thinking about how do we optimize for cost, emissions, and equity implications, and ensure that we move forward together. So how are we doing on the overall progress? This is going to be updated pretty soon by the Energy Commission. The current results indicate that 2023 was a significantly better year. So we're almost at 2/3 zero carbon. But just wanted to note that a significant part of that is hydro and nuclear, as you see there. So as we move forward, as the nuclear drops off per mandate today in 2030, you would lose that 10%, right? And then hydro, depending on the hydro year, whether it's a good weather year or not, that can go up and down. So overall, that progress, is going to be up and down a little bit, and we need to watch that. But it's also, something to be proud of as Team California, right? We're doing a lot of good things to make sure we move forward with these bold goals that we have. But then 2035, we have to hit 90% by law, and 2045, it's 100%. And between that 90 and 100 will be the hardest part for us to get through. So then kind of thinking about just reminding ourselves as we build the grid has to be built not only for making sure we serve the load on average conditions, but serve the load under extreme conditions. And as most of you observe, where you live, whether it's in California, elsewhere, we have droughts, extreme heat and fire, and different states and locations in the U.S. have different issues. We have to contend with all three of them and ensure that the grid can withstand those extremes and make it cost effectively. So let me kind of go into this just as a reminder, as you think about how these different resources play into the grid planning. For drought, we have this cyclical nature in California, right? And in some years, I think it was 2021, where we had for the first time some of the reservoirs bottoming out with no generation, right? And then we have to be ready for those kind of conditions. So drought is real and it's getting worse. The frequency of the cycles are getting more frequent, and also the extremes of the drought are becoming more. Wildfires, something that California is very familiar with, but to connect that to the intersection of specifically the grid planning, I would just call on the 2021 when we had the bootleg fire in Oregon. Given that California is an import state, largely on a net import state, a bootleg fire knocked out 4,000 megawatts in an instant, right? And so the transmission line being out, how do you make that up in that moment very, very quickly? And there are lots of resources. They could be community scale resiliency. They could be behind the meter resiliency, or larger assets that we might need. So then kind of lastly on the closing this up with temperature, just let me situate you on the slide. This is looking at expected changes, magnitude, and timing of extreme weather events or extreme heat. What you want to take away from this is in 1960s, right? You had these heat happening for a few months, and the extremes were not that big, right? So that the range was still between 103 and 110 degrees. But as you move forward in time, the band of months that we have to deal with extreme heat just continues to grow, and the absolute magnitude of that also continues to grow. So this becomes something that we need to contend with as we move forward. So then want to kind of put this in context with one of the critical parts of our transition. So when you think about the electric grid, today we have about 100 gigs installed in California. 40 of that is still thermal power plants, right? And an important part of kind of a clean energy transition is to move away from natural gas resources to other clean, firm resources. CCS is definitely something some of the LRAs are considering, and it's part of the scoping plan, but storage is an important part of this. So let's look at this chart. This is a heat map of gas generation. On the x-axis, you have every day of the year, and on the y-axis, you have the 24 hours. And it's pretty intuitive, right? I mean, we see that the gas is used in the months of summer, especially in the evening ramp. So as the sun goes down, wind takes a little time to come up. How do you balance the grid minute to minute and second to second, right? So that's where you have this need for firm thermal resources. And how do we construct the necessary resource mix that can get us away from the thermal resources? The other point I want to just make here is, as we move forward, the forecast indicates that the winter peak, especially in February, would be as high as summer peak, because we are going to lean a lot into heat pumps. So then we need to think about, how are we going to meet that peak, not only in summer, but also in winter months and maybe earlier in the day. So that kind of brings us into, kind of the planning for extremes. And I have just a couple slides to close off here. Just planning on extremes. Let's think about how the planning happens today, and each one of that has to be reformed. So first, the very first part is when we authorize procurement, are we authorizing the procurement to the necessary planning standards? And the planning standards are what we call the 1 in 10 loss of load expectation. And I'm pretty sure you'll hear that all day today. So, basically the 1 in 10 loss of load expectation translates to, as we plan for the grid and stochastically analyze the statistics of the grid planning, can we not have more than one outage every 10 years? That's the planning standard, right? So as the intermittency of resources get onto the grid, it becomes harder and harder to estimate, right? How do you ensure that even with all this intermittency, you shall not have more than one outage in 10 years? So once you plan for that, the first question becomes, are we authorizing that procurement? If we are authorizing it, then the next question becomes, are we building it? And there are many reasons why we might not be able to build it. It could be all the way from supply chain issues downstream to sheer ability to build transmission and interconnect these resources. So you have this whole overall, spectrum that we want to think about. And then you have this potential where these extreme events could happen. So how are you going to plan some sort of a cushion on the grid that continues to keep us in good balance on reliability? So then kind of this is not happening in isolation, electric grid planning. This has to happen holistically with combination, both from the natural gas transition, the petroleum transition, and the electricity transition have to go together. One of the core issues around the here is affordability and equity. So affordability, as we move forward, we have seen a lot of price increases, rate increases in the electric grid. Necessary investments, but the pain is really felt disproportionately by lower income households. So now, as we electrify, then an important thing for us to consider is who get to electrify their homes first. Usually people with the capital to be able to do that. And so if the wealthier households move to electrification first, then the lower income households would be left with the entire infrastructure on their rates. So some of the analysis suggests like 20-fold increases in natural gas rates, depending on who gets to exit first, because that infrastructure has to be paid by somebody. So you have that. And then as you go down on the electricity side, on the petroleum side, because we are electrifying our transportation, there is a supply-demand imbalance in the petroleum sector. And we could see the prices go up there. So we need to think about the system holistically, energy demand balance and affordability across all energy sectors. And how do we ensure that those that are more vulnerable amongst us are protected along this transition? So the investments are focused in areas where the need is the most from the state side. So just kind of, if there's one thing that I want to leave for all of you as you continue today, my kind of experience over the last 4.5 years in this role really tells me that the way to move forward to implement our bold goals is to be together, to have a recognition that this is not anyone's economy, but it is our economy. I'm quoting from uh, Emmanuel Pastor, Dr. Emmanuel Pastor from USC, who I really admire, talks about the importance for us to use the words our. This is our economy. This is our grid, our planning. So we do this together as one big team, understanding the trade-offs. There is no silver bullet. It's really about trying to think about all the solutions we need. And a lot of that, creating that togetherness is really reliant on trust, and trust of relationships, trust of institutions, trust of processes. And that's really is about this cyclical nature of engaging and not walking away from conflict, but engaging to understand the conversation with openness of curiosity. So in a trust and dialogue, be open to change. Let's keep our analysis as much as possible data driven, and build common awareness so we can have common solution set. So with all that, thank you for the opportunity. And again, as I said, oftentimes we leave energy and kind of the impacts, non-energy impacts, to the end, which I also did here. Is just to recognize that as we plan the system at a state level, the real impacts are at the community level. And we need to understand how the state planning intersect with community preferences. Where is that handoff point? And how do we ensure that community and local preferences are really a part of the state planning exercise? So that's all I have. Good luck for the day, and thank you for the opportunity to be here. Thank you.
Thank you very much, Siva. What a great presentation. Really central to being able to look at the context from the top down, and so we're very grateful for your wisdom and presentation. Next up, we have we're very lucky to have this next speaker with us. Brett Anderson is AccuWeather's lead climate expert and senior meteorologist. He's stepping in for John Porter. Brett is part of John's specialized team that provides accurate and actionable weather warnings and insights to businesses globally. Brett, we're very pleased to have you with us today. Can you please tell us what the future holds for this region? What's coming at us?
Well, I don't have some good news here, unfortunately. Things don't look too bright here as we go through the century, unfortunately, but I'll try to go through some details here as I share my screen here with you. Let's see. I think that's right. Nope, wrong one. Oh yeah, there we go. Okay. Let's see. Yes. All right, you see everything there? Okay. All right, we're going to start here. California climate trends and projections. Basically, going to focus on California mostly, but in order to talk about California, you have to talk about the nation as well. So, starting out with temperature trends, past, current, and future. What we're seeing here across the United States, and I focused on the summer here. When we looked at the spring, fall, and winter temperature trends over the last 30 years, especially in the southwestern part of the country, did not see too much of a trend. However, when you went to the summer, you clearly saw a significant trend over the past 30 years. Many more days where we're seeing extreme temperatures, and temperatures, per decade, we're seeing an increase anywhere from 0.5 degree Fahrenheit to as much as 2 degrees Fahrenheit per decade over the past 30 years. So very significant there. Now, obviously, with more heat, what we're seeing across the United States as a whole is, obviously, as you guys know, summer electricity use is on the way up. Has flattened out a little bit over the past 10 to 15 years a bit. I think part of that reason is what we're seeing in the Midwest and across the plains, and I'll explain that later. and also summer cooling degree days have been slightly increasing as well. Again, this is through 2020. Still waiting for the latest data on that. West seeing the greatest increase in hot days. The bigger the triangle, the higher the number. So across the Southwest, we're seeing a lot of large triangles, which means we're seeing an increase in more than 25 days of unusually hot temperatures across the region. Includes Southern California, Arizona, New Mexico, parts of Utah as well. Also along portions of the East Coast. But you see a lot of blue from Texas up to the Midwest. And there is a reason for that, and I'll show you in a little bit. Hot air covering more land area. Now look at the two lines, the orange line and the red line. The red line is hot daily highs. And again, we're seeing a noticeable uptick there, especially since the mid-1990s, when many of the climate scientists that I've talked to, we believe something happened in the mid-1990s, some type of tipping point. It's hard to explain, but something changed in the mid-90s. And you see this on a lot of different graphs. Trends changed a little bit in the mid-1990s. But the red line is the hot daily highs, clearly increasing, but it's the nighttime lows that we're seeing a much greater increase in the nighttime extreme low temperatures. So nights are rapidly getting warmer, not just in the Southwest, but also across much of the central and eastern portions of the country as well. So heat wave characteristics are changing. Heat wave frequency clearly on the upswing, as well as the heat wave season, a steady increase there. So that's basically looking at the start of the heat wave season in the end. So it's clearly growing. Heat wave intensity fairly flat. Duration has seen uptake a bit in the past 10 to 15 years or so, but the frequency and the length of the heat wave season clearly increasing the most compared to the other two. And this is going back since the early 1960s. So what is the future of extreme heat at the local level? And a lot of this data I got here from our friend Steve Root from AccuWeather. He compiles a lot of neat, interesting data using his own equations, also some of the climate emissions scenarios as well. So, oops, sorry. So first, I'm going to talk about the representative concentration pathways, RCPs. We have basically, these are different emission scenarios which we use to project future temperatures. And therefore, we have the RCP 2.6, which is very low future emissions. This is probably, unfortunately, the unlikely scenario. And then we have the low to moderate future emissions, which is what right now we're kind of on track with, closest. Again, things can change. And then we have the very high future emissions, which is certainly the worst case scenario. So we're going to look at RCP 4.5 and 8.5 for reference. I'm going to start in San Bernardino using RCP 4.5. Now today, currently, we average about 45 days, give or take. It varies by year, of course, but as an average, 45 days per year of 100 or higher in the area. By 2015, using the mid emission scenario, this doesn't change too much, even through 2075. Then we see an uptick by the end of the century. Temperatures over 110, not much change there, at least for San Bernardino. But when we get into the high emissions, the worst case scenario, you can see a pretty good uptick by 2050 of over 100-degree days. And then really way up there by the end of the century, 104 on average days above 100 degrees in the worst case scenario with the emissions, and then 21 days over 110 degrees. So not very promising there. Riverside, fairly similar. Again, 29 on average today, 100-degree days, getting up into the 30s by 2075 or so, and then up almost near 60 by the end of the century. Again, this is the more likely scenario. Not much change in the 110 or higher degree days. And then the worst case scenario, getting upwards near 62 in 2075, 91 days above 100 degrees on average by the end of the century, and 22 days on average above 110 in Riverside by the end of the century. Things really get bad. Finally, Palm Springs, the hot spot here. So I used 105 and 115 for reference. So right now we average about 94 days, reaching 105 or higher, 116 days of 115 higher. Again, getting up above 100 by 2050 in terms of 105, up 112 by the end of the century. So not a huge change there. And then bumping up close to 20 as we get towards the end of the century, above 115. But again, the higher emission scenario, bad news here, 131 days above 105 by 2075, 142, and then 70 days of above 115 degrees by the end of the century, if again we have the worst case scenario in terms of greenhouse gas emissions. So precipitation trends, national, regional. This is an interesting graphic. Percent change in precipitation across the area from 1901 to 2015. And you can see clearly the Midwest, Southern Plains getting wetter, even parts of the Northeast. Southwest, though, getting drier. It's no surprise. Many decades ago, climate scientists projected drier areas will get drier and hotter, wetter areas will get wetter, and that seems to be the case in general. Reason being, why we're seeing this, the Gulf of Mexico is warming rapidly, more heat energy there. So we're seeing stronger systems, more moisture coming up from the Gulf up through the Mississippi Valley, up into the Midwest, and therefore more cloud cover, more moisture, heavier storms, more precipitation, less heat. We think that's the main reason for that. Oops. There we go. Okay, so heavy precipitation events becoming more common. Again, this is more across the central and eastern part of the country. Big change going on there in those areas. We're seeing, again, since the 1900s through the 2000s, again, not much change through the 1960s, 70s, and then a clear uptick once we get into the 1980s and through the 2000s. Oops. So drought getting worse across the Southwest. Average change in drought across the 48 states here. Southwest seeing the biggest change, especially Southern California, unfortunately. We're in our neck of the woods, and parts of Arizona. Again, Midwest, Northeast, Mississippi Valley. No issues in terms of drought, just getting wetter. Increasing Southwest U.S. drought severity. So again, this is the severity of drought, extreme, basically talking extreme drought. And again, not much change through the early 1990s, late 1990s, seeing a lot more extreme drought across the southwestern states. Again, a tipping point showing up a little bit in the mid 1990s. Not a good trend you want to see. And again, we saw this graph at the start here, a little bit here. Very cyclical graphs. Every few years, we're getting into droughts across California. Not unusual, but you can see a lot more darker colors showing up in recent droughts. So the droughts, yeah, they're coming and going about the same rate, but they're getting worse, more extreme. Wildfires related to drought, of course. Not much change in the frequency of wildfires, fairly flat since the 1980s. I think a lot of us are aware of that, but big problem is the size of these fires. They get much bigger. Year-to-year variability, of course, but the trend is unmistakable across the United States, and we're really seeing that across the western portions of the country here. Drought, wildfire extent clearly getting bigger. Bigger fires producing a lot more smoke and a lot more damage. And again, this graph shows the expansion and damage from wildfires, moderate to high, starting to grow a little bit more in relation to the low or unburned damage from some of these fires. So things are clearly getting worse, to no surprise. So why are we seeing bigger fires? Several factors. Worsening drought, of course, higher temperatures. Again, all a product of climate change. Earlier meltdown of snow, seeing that across the entire country. So the fire season's getting bigger because we're losing the snow earlier, and it's starting later. Insect damage, this is more up across the Pacific Northwest. Trees are dying, or dying trees or dead trees are much more susceptible. Also leave a lot more litter on the ground, and so fires spread a lot much quicker than mismanagement of land. We're going to look at the Climate Extremes Index. This basically evaluates the percentage of extremes that we see of much above or much below average variables, temperature, precipitation, drought, or tropical cyclones. Obviously, tropical cyclones are not an issue for California, so we took that out. But across the Southwest, again, things fairly flat up until the mid-1990s, late 1990s, and then we're seeing a lot more extremes showing up over the past 20 plus years or so. Certainly concerning, no doubt about that. Daytime heat events, frequency. And again, this is daytime. And if you notice, again, things fairly flat through 1990 or so. Then we start seeing more extremes across locations in Southern California, listed to the right there. And then just over the past 7, 8, 9 years or so, really starting to see more days of extreme heat. Nighttime heat events, and I showed you this earlier, nighttimes are getting warmer more quickly than daytime are. So the night's a big problem here. And you can see over the past 10 years or so, really showing up a lot of extreme warmth during the night. So that's a big change showing up here in recent years. So very worrisome, no doubt about that. So rapid swings in extreme weather. One thing I want to mention is I just plugged this in the study here. New study is showing that the transition periods between one extreme to another, the opposite, have shortened in recent decades, basically giving communities and business less time to respond properly. So we're going from one extreme to another much more quickly than we used to. Very interesting. More studies needed on this, of course. And again, California billion disaster type counts by month. You can see the warm months are the big problems here for disasters. And again, wildfire and drought are the big problem. And then you can see billion-dollar disaster events clearly on the uptick since 2000, fairly flat before that. And again, things certainly trending in the wrong direction. And finally, just finishing up here, weather and climate hazard risk. Riverside County, not in a, certainly one of the higher counties across the lower 48 here. A lot of southwestern counties certainly, and with that, also South Florida. So that's it. Thank you. Fred?
Brett, really interesting, very data dense. Not a good outlook for this area. I guess really what it means is that that we use a hockey analogy. The great one, Wayne Gretzky, used to say he played the game to where he knew the puck was going to be, not where it was. So really what we're talking about is how to adapt to what's coming.
Exactly. We need to adapt.
Yeah. So very interesting. Thank you very much for this presentation.
Sure.
Next up, we have Eduardo Garcia, former assembly member and now lecturer at UCLA. Over his many years as assembly member, he has had a major impact on the formulation of clean energy policy in California. I'm sure he'll bring all his formidable understanding of both legislation and politics to his students at UCLA, and to us. Please welcome Eduardo Garcia.
Good morning, and thank you, Fred. And it's good to be on this panel with such great individuals who have been doing some of this work for far longer than I can claim I've been in this space, but certainly have served as mentors in many ways. And I see a few of them here today. I'd be remiss if I didn't say I'm also lecturing at the Policy School at UC Riverside. Given this is a UC Riverside event, I think I should make that known publicly that it's been an honor to be able to serve at the Public Policy School there at UCR, at our alma mater. And I'll shout out to UCR with my UCR coffee mug here. I put down some thoughts. I don't have any slides, but I wanted to just jump right into the question of, is the grid ready? And I think from a technical standpoint, we could all agree that it isn't. And there are a number of reasons why. We can go through in detail or at a high level and leave some room for others to speak about this as well and answer some questions and give some answers after the presentations. But look, the reliability of our grid system really has been at a place where the inability to build efficiently in a way in which it's done in an environmentally sound and safe way has been one of the biggest challenges that we see. The infrastructure needs that we have are really second to none in many parts of the state of California. We've put forward some of the most ambitious energy climate policies of anyone in the world, and certainly here in our country. And we're at an intersection today where the policies that we're seeing from the federal government are clearly not in line with the policies that we've been pursuing over the last 25, 30 years. That creates a tremendous amount of uncertainty when it comes not just to trying to achieve those objectives, but our ability to build an infrastructure that aligns with this transition that we've laid out for the last few decades. I'd like to think that the willingness on the part of legislators in California, regulators in California, and members of the executive team are all in line with this vision and this mission. But it's the practical side of how we get there, navigating through the areas that we ourselves sometimes create as our own demise and our challenges. I'd like to, talk a bit about, the prior presentation and the uncertainty of climate playing a key role on what is a unreliable system to deliver this clean energy goals and objectives that we've laid out. We live in the Coachella Valley, and it was made reference to in terms of the temperatures that we experience in this area. And we have a system that is shared when it comes to providing power between a public utility and a private one, that oftentimes we see these blackouts and these challenges, both from a maintenance standpoint, from a infrastructure development and planning standpoint, but also just from a overload of power consumption that we have during those particular months. We have a very high population of seniors and individuals on fixed incomes that the issue of affordability is something that consistently is presented as both a challenge, an obstacle, and a component to deliberate and debating these clean energy goals and objectives that we've set forward and that we continue to pursue. And it's become a very easy narrative to pin on these objectives to try to set back where we're going. The cost of these policies is a narrative that we consistently hear is one of the biggest challenges that we have. From a grid standpoint, we know that there are efforts, and the Inflation Reduction Act passed by the prior federal administration focused tremendous amount of attention and intentional investment to come to California for the purposes of building up our infrastructure, our transmission systems. But this new administration has put a pause on much of what was envisioned could happen in California to build a stronger, resilient energy grid system. And so that becomes a major interruption and an uncertainty as we attempt to achieve many of these objectives. We are at an intersection of what the future of our climate policies and our renewable energy policies will look like in the next few years, decade, and years to come. The question is, as California, as industries, as governing bodies, and as communities, what will we be willing to do to ensure that we can continue to move this agenda forward and bring along those in the communities that have disproportionately seen the impacts of climate and the uncertainty of not having a reliable grid system for basic, simple economic development, growth in communities that are both poised to see this activity happen, but also are hungry to see these opportunities to happen, to be able to ensure that people have good paying jobs and are able to provide for their families. That leads me to the point of equity when it comes to our policies in the clean energy space and our climate arena. Our policies must be centered around those unique dynamics that we see in our local communities. And the issue of a grid system being reliable is fundamental to not just economic growth and development, but public health as a whole. And so the question for me that was asked to speak on is the grid ready? I think from a technical standpoint and from a practical standpoint, we can agree that it isn't. But that does not mean that we have not been able to make some strides in making sure that we move in that direction to continue to build on the legacy that California has as a leader around the world when it comes to our clean energy and our climate goals and objectives. And we've got plenty of people with us today, and perhaps those watching, that can help us navigate through those challenges, including the challenges that we have in front of us as it pertains to federal government intervention when it comes to our goals and objectives here. I really appreciate the opportunity to open up with these remarks, and I look forward to the dialogue, the questions, and the answers from the audience and the other panelists here today. And thank you again, Fred, for the invitation, and Mayor Loveridge for having us here again today.
Great, thanks very much, Eduardo. The experience that you've had as a legislator, I think is really sort of foremost, and what you can bring to both students and to the rest of the community, I think is very, very highly valued. So thank you very much for what you've done and what you're continuing to do. Next up, we have Professor Dan Kammen from UC Berkeley, who could not be here with us, but who has, along with me, done a video. So take it away, Dan.
Okay, Fred, just give me a second. I need to upload it.
Yep.
Can you see the video? No.
I think it's just starting to load.
Okay, give me a second.
Right now, I think I see a beautiful Greek island. Here we are.
You can see it?
You can see it, so yeah.
Okay, I'm gonna play the audio.
Well, next up we have a good old buddy of mine, Dan Kammen, who lives in Oakland and has worked at Berkeley as a professor there, professor of energy and other things for many years, and has been involved in the IPCC and so on. Just really happy to have Dan with us. So take it away.
Well, Fred, thanks so much both for your long-term friendship, but also for pushing ahead the cause of not just clean energy, but as I'll kind of comment in the coming few minutes, energy and justice and energy, meaning that you get one with the other if you are at all smart about how you deploy things. And I say that because we're obviously in a horrific political moment where the US is making anti-community, anti-climate, anti-women, anti-minority. And I say that we're not going to solve all the world's problems with clean energy, but good bones make good foundations. And so one of the things that's so exciting about the Solar Valley Consortium is to recognize that everyone and every institution involved is not after the same thing. There are some groups that are after clean energy, others after low cost energy, others after low environmental footprint energy, others after energy and racial and gender justice. And particularly at this moment, with a federal government that is trying to destroy itself, and a California government and a New York government and a Washington state and New Mexico that are trying to push back and be civilized, kind members of society, we really need to recognize that the benefits of clean energy are just about as diverse as we're willing to support. And so what I wanted to open kind of, my part of the comments here is just to note how strong those bones are. So for example, we now know, and we've known for about the last 3 or 4 years, thanks to really great reporting by people like Sammy Roth at the LA Times and by the team at Bloomberg New Energy Finance, that clean energy is now cheaper to build new clean energy projects than it is to operate existing fossil fuel projects. And that's an amazing statement. We didn't think we would get there in 2025. In some ways, it sounds like the battle should be over, that we should be doing clean energy everywhere. But as we've also learned, we are also subsidizing fossil fuels globally to a tune of 3 to 5 times more than the total global investment in clean energy. And despite that massive subsidy for fossil fuels, we've just seen that in the first quarter of 2025, clean energy amounted to 40% of global generation. So we are at this remarkable moment where clean energy is doing everything we've asked it to do and more, and yet we are still putting the brakes on it, and we have a new Secretary of Energy and a head of the EPA, if you can even call him a head of the EPA, that are doing their best to dismantle the best of American innovation ingenuity, clean tech companies that are leading the world in what they're doing. It is a remarkable time of a country eating its own and eating its best. And we are watching the government try to take $9 billion from Harvard and 800 million from Hopkins and $1 billion from Cornell and 600 million from Northwestern. And they'll be going after the state universities next. And Columbia already capitulated. And we are now seeing efforts to take on higher education based on a belief in DEI, based on a belief that diversity benefits not only the formerly discriminated against, still discriminated against, but also the rest of society. And I say that as someone who works on energy access, works on the just energy transition. And at Berkeley, we have a roundtable on climate, environmental justice, researching clean energy, land use issues, indigenous energy, a whole variety of things. We just saw University of Michigan decide they would close their DEI programs. And so what you're doing at the Solar Valley Consortium, what we're seeing in terms of leveraging what clean energy can do, meaning making poor communities energy secure at low cost, introducing energy storage as a competitive business, building a solar workforce that now is significantly larger than the total employment of all of our utilities in the state. These are all remarkable things that when my unit, the Energy and Resources Group, was founded by John Holdren and Art Rosenfeld and many other luminaries in the 70s, those are things that if we told them, yes, we've achieved all these things today. Clean energy is now the least cost form of energy. Energy storage is as active an area of innovation as any IT field. Clean energy and justice are now married, at least in California, maybe not in DC, certainly not in the Wyomings and Arkansas, but here in California they are. And we have seen this remarkable process where technologies that nobody thought were going to be part of the equation are now there. Offshore wind, the US is way behind. Scandinavia and China, South Korea are rocketing ahead. Space-based solar is now on the horizon. I'd like to think that fusion is going to be making a serious appearance now that Livermore has demonstrated that fusion is possible. And I'll end my comments with a return to fusion in a second. But all of these things that I'm describing are features that if you had told us of the late 70s, early 80s, if we had achieved all these milestones, they would have said, you have won the just transition. And yet here we are, a government that's at war with its research, a government at the federal level that is basically trying to dismantle the growth areas of the economy, including clean tech, that it is amazing how far from victory we are, even if all of the fundamentals seem like we're there. So it's a critical moment for everything from researchers to communities, to cities that enact green energy policies, LA 100 as a plan to make one of the world's major cities an entire clean energy leader, arguably to catch up with places like Copenhagen that have already basically done that. But we are at a place where the energy mix is one that allows us to make choices that are pro-humanity, pro-empathy, no matter what Mr. Musk thinks, and compassion not being a good thing. All of these are on the table for us now, and clean energy plays a big role in it, and yet we are struggling for a foothold given the changes at the federal level. So I'm delighted at both the details of what the meeting is about. How do we do land use issues right? How do we build solar always now with storage? How do we make it so that every vehicle is vehicle to grid, not just able, but is actually a mobile storage device? Because that's what cars are now. Cars are now basically big smartphones where you drive them around, plug them in, they can do all kinds of things. We're not taking advantage of the smart side, but all of this is on the table. And so we, in a still civilized society, most of California's civilized society, I can think of a few pockets, but that's what's on the table, and that's what's at risk if we self-censor, if we give in to this right-wing dictatorial federal force. So it's an exciting moment. And I guess just to highlight how remarkable it is, when I went into energy and kind of out of theoretical physics and out of cosmology, I took a course from a plasma physicist, actually Nicholas Blumbergen, who won the Nobel Prize, and we talked about fusion and the joke that fusion is 50 years away, and it's always been 50 years away. Well, you know, I think we're at a very different point today. So as someone who wanted to be an astronaut, is now an energy researcher, works on these topics, I actually think in 2070, when sadly I will not be around to collect on the bet, I think in 2070 the world is going to be 70% powered by fusion, but half of that's going to be 93 million miles away. And so a world where fusion does what small modular reactors and things have so far not done, but I think fusion is going to do for half of our energy, or call it 35%, another 35% from solar, and other clean sources from wind to geothermal making up the rest. That's a world that's now entirely in reach. But if I'd said that when ERG was being founded, they would have said, well, you really are writing your own favorite version of Larry Niven or Isaac Asimov or Anne McCaffrey or Ursula Le Guin science fiction, as opposed to what we could be creating today. So thank you for doing the meeting. Thank you for getting all the voices heard. And thank you for leaning in on the just energy transition, not just the energy transition. So thank you so much. And everyone enjoy the meeting. Sorry, I'm not with you in person.
So there you have it. That's Dan's comment on where we are today and where we could go with clean energy. We have now time for Q&A, a few minutes for Q&A. And there is one question in the Q&A box, and it's addressed to Eduardo. In regard to climate resiliency, specifically in Latino communities, what are the common concerns in Eastern Coachella Valley area, and are there specific concerns that arise closer to the Salton Sea as well?
The populations around the Salton Sea are majorly concerned about the air quality issues related to the Salton Sea. the public health implications that it has to the families that live in and around that area. And more people are moving out to that area, not by choice, but certainly by circumstance, the affordability of housing in and around the region in itself. But as it relates to the grid, as it relates to energy reliability and affordability, we have a tremendous amount of challenges in that area, from an antiquated infrastructure to a lack of sustainable existing infrastructure when it comes to high winds, when it comes to storms, when it comes to these extreme heat circumstances that we face on a regular basis. We literally have a situation out there where if the wind blows beyond normal, miles per hour, those poles are falling and there are people without energy. Although the local utility has done a better job in its response and providing what are backup solutions or temporary solutions, it's still a major, not just an inconvenience, but an interruption to people's life, to people's well-being, and certainly puts a lot of people at risk when we see those types of interruptions. But populations in the eastern parts of the Coachella Valley are concerned about affordability, energy reliability, and when it comes to the Salton Sea area, we're talking about public health concerns related to air quality issues. And although the state has made some major progress when it comes to investing, when it comes to inclusionary dialogue with the communities, we have a long ways to go there. And this is an issue that I know firsthand, not just because we live within proximity, but because it's an issue that we worked on for almost 2 decades as a policymaker at the local level and at the state level. Thank you for the question.
Do other panelists have questions?
Call has been forwarded to voice.
Okay, all right, then it looks as though we can move on. We were going to be having a presentation from Southern Cal Edison. I hope that Manuel will be joining us shortly, but let's transition to John Hildebrand, who is no stranger to Solar Valley's conferences and webinars, and we're very pleased to have him back again. He's Riverside County's Director of Planning. He has over 20 years of professional planning experience and has been particularly helpful in Solar Valley's events, explaining the barriers and potential solutions to the deployment of large-scale solar and storage in Riverside County. Take it away, John.
Thank you for the introduction. Good morning, everybody. John Hildebrand, Riverside County Planning Director. I have a quick presentation here. Let me share it real quick and I'll get it going. Okay. Can everybody see it all right? There we go. All right. Well, as I mentioned, I'm the Riverside County Planning Director. I've been here for about 10 years at the county. Today has an interesting theme from all the panelists so far. It's really about resiliency, sustainability, and fire-related issues are a big one, which I'll be touching on as it relates to entitlement planning and moving forward with solar production and just general development through the county as a whole. For those of you who don't know, the fire hazard severity zone maps have just been released by the state of California. These were released on 3/24 this year from the Office of the State, and it remaps out the high fire hazard areas and the local area responsibilities as well as the state. And this does a whole bunch of things for entitlement, and we'll cover kind of what those are. These were pushed out very quickly. There was really no public comment that was taken into consideration for these maps. It was a state mandate to update these things as a result, of course, of all of our major fires, LA fires, and everything else that's happened recently. Even though our county and our fire department has some challenges with some of the areas, how they were mapped, we're stuck with this really at this point. This is what we have to adopt. And these maps per state mandate must be adopted by 7/22 of this year. So our county is very quickly going through the maps, trying to understand what this is going to, how this is going to impact development, what it's going to do for the entitlement processing, construction side of things, and the whole adoption process. So these maps will be rolled out, part of our county's general plan very shortly. And some of the considerations that happens when you have these fire maps like this, is a result in new developments requiring greater setbacks, points of access for residential. This changes fundamentally the plant materials that are allowed to be used, requires a larger area for defensible spacing, and of course, construction materials themselves are going to be fundamentally changing. And so what does this do to solar production? How does this impact the solar industry with these fires? And I'll get to that here in a little bit with some considerations. Here is a before and after map showing kind of the downtown, Moreno Valley, Paris area. On the left is what the fire high severity zones are mapped today. And on the right is the delta, the changes from the new maps. And this is just a snapshot from an interactive live map that we have available now on our county website. But of note, and you can see that the very high fire areas have almost doubled, and this is county-wide. So as of beginning this year, there were about 11,000 acres mapped in an existing very high fire zone, and that has now changed to almost 23,000 acres county-wide. So a lot of the mitigation and abatement strategies we were already doing as it relates to very high fire, but now the area and the boundary has changed. So this is going to be impacting quite a bit of development here in the county, which we're still sorting through exactly what that means. There's a great interactive map on the county's fire department website that shows the before and after. It's like a little toggle switch. You can see kind of where they were before and where the high fire areas are now. So how does this impact kind of the area out in Lake Tamarack, the desert center where most of our solar production is occurring? That area wasn't really mapped before because there wasn't much out there. This version of it is not too egregious. It just shows some moderate fire hazard areas. And again, what does that do for development out there with solar? And we're not quite sure yet is the short answer. We're still working with our fire department to understand if there's any greater requirements for setbacks, any greater mitigation needed, access, et cetera, for future solar production out there. And we'll certainly have some helpful sort of one sheets or regulations related to it that'll be pushed out shortly here. We always get asked, how did these high fire areas get mapped to begin with? What's this magic black box behind the scenes that they use to determine a very high fire area versus it being not? And it's kind of at a 30,000 foot level where they do these mappings, and they do take into consideration the terrain, the physical plant material that's on the property, the vegetation, historic fire data, weather patterns, and really importantly is the ember spread based upon weather patterns. And so they create these areas of very high fire when they know that the embers have a chance to kind of move more quickly, a larger range, larger area, and then they call that a very high fire hazard because of the challenges associated with the movement of those embers. So what does that mean for the county, and what are some of the barriers and challenges that we're experiencing from the entitlement side, from the permitting side on our end in our planning department? One of the newer things that's come up more recently that I've had to deal with on the entitlement processing is battery storage. And the challenge with this is it comes in two flavors for us: battery storage in conjunction with a solar production farm or a standalone battery storage facility itself. We've been doing solar and battery storage for a very long time. We have our permitting process, we have our regulations, entitlement opportunities to do all that. What's new and different for us is this desire and these needs to have a standalone, large-scale battery storage facility in areas that we haven't seen being developed before, and we don't have the rules for that yet. It's a land use that we're still sort of exploring on how to create regulations around it for a number of reasons: to ensure that the safety of the community, to ensure the safety of our fire personnel in case there's a challenge out there. And we're looking at opportunities for creating standards and regulations around standalone battery storages that can make it work for everybody. Currently, those regulations are in a California Fire Code, Title 24, and then many jurisdictions have their local standards for battery storage in addition to that. There is a ton of new proposed state legislation around battery storage that tries to deal with ensuring safety, emergency access to them, and fire management plans in the event one of these things goes down and they have to be taken care of. And one of the things that is a consideration for battery storage areas is there is a real need for more fire resources. There's a higher request for inspections. There's a higher need for fire services in the event one of these things goes up. it's not just a one and done. They go out and they take care of it and they're done. These things have a tendency to be really unsafe. They burn for days on end, especially if they're inside of a structure or building. We've had a couple of them out here in our area that I'm sure all of you are aware about. It's taken weeks for them to be able to abate and put these things out because they physically can't get into the buildings. They put them out, they spark back up again, and they're really dangerous when they're on fire. So our fire department has a real vested interest in establishing our regulations and cost recovery mechanisms for battery storage. So, this adds a whole nother level of regulatory challenges, obviously for the permitting side of these things, but we need to make sure that we're safe, our fire personnel are safe, and the community is safe where these things go in. And this is the balance that we're trying to achieve with all of this. Stuck here. Next slide. There we go. So mentioned legislation around battery storage, the energy systems. This is just a small list of the assembly bills and Senate bills that are coming to this legislation area. They really have to do with management, safety of these things. And the last one, the AB 434, is an interesting one. It puts almost a moratorium on battery storage development and entitlement processing until you have a set of minimum standards for construction and management and conditions around these things. So it can be a challenge if these things get enacted and in place. We're working towards all of this, as are most jurisdictions. We do want to continue supporting battery storage. That's something the county is in support of, but we need to make sure that it's done responsibly, it's managed well, and there's an opportunity for our fire team to be able to service these things as needed moving forward. So this is a short list. Where these end up, we're not sure yet. Let's see, I had one more slide. Our decision-making process for what we do here at the county is really revolved around striking a balance, right? We have all these competing priorities at the state. And these competing priorities have to do with build more housing, create more jobs, create more renewable energy, ensure that production and development continue. On the flip side of this coin is this competing priority also at the state level, conserve your conservation areas, don't build in high fire areas, reduce your water and energy consumptions, manage your plant palettes so that you only use materials that are non combustible, that won't cause problems. But we also require robust planting. So those are the two competing things on each side of this. And so when we look at solar production and battery storage and really any developments in the counties, we're very critical on considering this balanced approach for a meaningful, responsible development countywide. And I only see, the state's interest becoming more and more competing with each other, as we're seeing on an annual basis with the housing legislation and requirements for renewable energy. It makes it a challenge for us as planners to create that balance and keep things moving forward. And we're certainly continue working with the industry, with the state, with the conservation folks, and try to make it all work and come together at the end of the day. And that's my presentation. If you got any questions, let me know. I'll stop.
Thank you, John. From the county's point of view, you have a lot of competing interests. I'm very impressed with the way you've been able to sort of wrap your arms around them. Looks like V. John has a question. Please go ahead.
Thank you, and thank you for the presentation. I just want to emphasize the importance of understanding the need for standards and best practices for battery safety. This is the Moss Landing explosion and fire was extraordinarily dangerous. More than 1,200 people were evacuated, and Highway 1 was closed down for 48 hours. So it was a very big deal. Now, it was a technology and a company that were not state of the art. But the fact is that we don't have a uniform set of standards. I think this is something for the Energy Commission to undertake. I think there's good data available and there's technologies available, but I think the work that the county is doing, particularly identifying areas where the wildfire risk would intersect with potential battery fires is a very useful exercise. So I just wanted to comment.
Thank you, John. So the question becomes, we know we have to build a lot, both batteries and solar, large-scale solar and rooftop and all of it. The question really is, how does this look from the point of view of industry? And so we have with us now Scott Kulke, Senior Director of Solar Development for EDF Renewables Western Region, with a particular focus on California, the California ISO and the Western Electricity Coordinating Council, that's WEC. Since 2018, EDF Renewables has completed over 1 gigawatt of projects in California, including its Valentine and Big Bow solar projects in Kern County and the Desert Harvest, Palin, Desert Quartzite solar projects in Riverside County. We're very pleased to have Scott as a panelist. Please take it away, Scott.
Great. Thank you, Fred. Thank you for inviting me today. Pleasure to be with this good group. I'm going to try to share my screen. So give me one quick moment to do that. Okay, hopefully my screen is clear. So again, thank you for the introduction and inviting me to the Solar Valley Annual Conference today. I've been in renewables development for 15 years and 10 years at EDFR, and I really enjoy working in this space, creating opportunities for economic development, grid decarbonization, and hopefully leaving a cleaner future for generations to come. Today, I want to cover not only land availability, but a developer's view on the why, state of the renewables market, and utility scale land use and transmission thoughts. Let's see here. First, a plug for EDF. We have focused on renewables development in North America for about 40 years, covering all utility scale products such as onshore wind to utility scale solar, battery energy storage systems, and moving into more microgrids, electric vehicle chargers. In California, we believe that we are homegrown. We've been here for about 40 years, starting off with doing operations and maintenance for wind projects that were growing in Palm Springs. Currently own and operate over 2,000 megawatts in California alone. Half of that is in Riverside County along the I-10 corridor. And we expect over 600 megawatts of PV plus storage to be operational in the coming years. So why are we here? Well, the market is pretty strong. The demand for renewables remains significant, and general load growth is growing as well. This low growth is due to many reasons: manufacturing reshoring, data centers, electrical vehicle adoption, and greater electrification. And this low growth is being met with aggressive goals and action to increase renewables through 2035. CCAs and IOUs and munis are having significant procurement. The biggest municipality in the country, LDWP, is striving to reach 100% carbon-free energy mix by 2035. And to address this, in the most recent draft TPP from CAISO, planning to support 76 gigawatts of additional procurement on top of existing resources by 2039. This will ultimately result in a high and real opportunity, but a strain on the system. In California, there are many high barriers to entry, and cost to participate will drive significant out-of-state procurement. So from the developer's perspective, we look across industry, federal, state, and local issues. And let's be honest, the negativity this year is greater than it has been in years past. What's great is that demand is there. I've been here long enough where demand was pretty flat. Now it's growing absent of RPS goals. However, we are seeing challenges on the procurement side, most notably on high voltage equipment, leading to long Equipment delays, up to 3-year lead times is not unheard of. Costs have increased materially since 2020. I've understood that in some parts of the country, renewables are twice as expensive than what they were in prior years. So off-takers are seeing higher prices when renewables are supposed to be some of the lowest cost resources available. On the federal side, Inflation Reduction Act continues to have great benefits and strong incentives for marketing and renewable siting. That said, the IRA is under continued threat of significant modification or repeal from the current administration. So we, EDF, along with others in the industry, are mobilizing outreach to Republican districts to support the IRA, given the outsized benefit in their districts. Plug here, if you have a Republican congressman to reach out to, great time to do it. Trade restrictions. I learned yesterday from our procurement team that we're seeing anywhere from 2 to 3 days a change in trade policy. It's very difficult to keep up with. On the staffing side and executive orders really being kind of pushed aside. The DOI is expediting permitting for the oil and gas industry while undercutting or delaying permitting for renewables. And unfortunately, we're seeing this in threatening declared monuments such as Chuckwalla, which was a recent example of how various stakeholders can work together to achieve multiple goals of sustainability. On the state side, we see consistent and continued support for legislation that's pro-renewables. One example of this is Senate Bill 540 that is in front of the California legislature today that will not only enhance renewables in the West, but open up markets in the West, reduce curtailment for projects that are in the state or outside the state. It's supported by labor, unions, utilities, CCAs, and environmental groups. So we're hopeful this legislation will go through. Offtake desires there. If a project can be permitted and transmission's available, very strong chance it will find offtake and operate. On the transmission side, it's clear that CAISO's TPP is planning for growth. The interconnection procedures enhancements are providing incentives and pathways for receiving deliverability. It can challenge developers by requiring greater commitments than what we've been used to, but it also reduces queue sitting or blocking by poor actors. We're seeing in 27, the active solar energy exclusion shall expire. Developers are planning for this. This will increase costs for projects, but on the flip side, there will be more money going to host communities to support siting of our projects. And then locally, jurisdictions that have historically been supportive remain so. Developers are being proactive to manage agency and community input, and that's really important for the success of our projects. That's important too, because its pre-construction permits are becoming more complex. We're getting more scrutiny for what we once believed were settled issues. So communities are asking what's in it for them. Development on federal lands do generate revenue, but we could see that could be increased further. And there's been recent legislation by California Rep. Mike Levin. The Public Land Renewable Energy Development Act has been reintroduced that, if supported, would increase revenues on federal lands to local areas. So let's talk about land availability. Developers like us consider a number of factors when siting a project, and they are years, if not decades, in the making. Siting a utility scale project successfully can be a lengthy and complex endeavor. So, for example, planning for a 100 megawatt solar project may need 800 acres of contiguous or near contiguous land to account for zoning setbacks, easements, sensitive areas to ultimately be successful. In San Bernardino and Riverside counties, it is difficult in many cases, not possible to comprise development solely on private or public land. So there is usually a mix of public and private land and overlapping jurisdictions having site over the projects. Also, in these counties, most land is off limits for development. BLM exclusion areas, national parks, preserves, and monuments, Department of Defense. So there are areas that are focused specifically with solar energy zones, development focus areas, or variance areas that are where products are permissible to be built. The challenge can be that during during the phases of development, because of the long lead time, these areas can be further compromised from development, or new, for example, new species may be listed, or protocols for surveys. John Hildebrand mentioned fire risk areas that are being recognized, and that could have a further impact on siting. So, for a developer in California to be successful, a lot of patience is needed, and pushing for the market. But if you can do that and think about a good 7 to 10-year time horizon, like, it's possible your project can be successful. Additionally, with land, we need to focus on transmission. Access or location to transmission is crucial. And not just access to transmission, the physical infrastructure, but that being that there's deliverability or pathways. So thus, projects tend to be clustered in areas where there's good land use and areas of transmission upgrades. So areas that we see that are continued for development to include areas near Kramer, which is up in San Bernardino, west of Barstow, or along the I-10 corridor, where projects have continued to grow and develop and meet load for Southern California. As far as upgrades for the transmission system, we're starting to see that come into action. So 2022, 23, a lot of approved upgrades occurred, but it's going to take some time to see those come to fruition. So anywhere from 2028 to 2032 until we get those. So again, patience and ability to read the market and where it's going to be going is important for developers to be successful in this area. So some key takeaways. Demand remains strong in California. Available land near transmission is and will continue to be a significant constraint. Our focus on proactive engagement with communities and agencies shall achieve success and demonstrate a win-win. So, considering resource protection, jobs, economic benefits for host communities. We continue to advocate and seek action funding to address the transmission improvements we're seeking. And deployment of clean energy will continue to require all forms of solutions, including those of out-of-state resources that will be important to meet the demand in California. So I can stop there, and I'll stop sharing my screen.
Okay, Scott, thank you. Thank you very much for this. Really important to understand the industry's perspective on this. You're dealing with long lead times for equipment, perhaps lack of interconnection and transmission availability and deliverability. Next up, though, we have Manuel Avendaño, who is Southern Cal Edison's Senior Engineering Manager for transmission planning in this region. He leads a team of engineering managers and engineers as part of Southern Cal Edison's integrated system planning and analysis, collaborating with the CAISO, the California Independent System Operator, and the Western Electricity Coordinating Council. Southern Cal Edison, I should note, has been particularly helpful in providing detailed information concerning their plans in the region. So welcome to Manuel. Please take it away.
Good morning. Can you hear me? Can you see my screen? Excellent. Okay. Well, hello, everyone. My name is Manuel Avendaño, and I lead Central System Planning at Southern California Edison. And today I'll share some of our perspective on key transmission-related barriers to solar deployment and how we're working to address them. I want to focus on CAISO's current planning cycle, interconnection trends, near-term implementation efforts. So let's start with the draft 2024-2025 transmission plan from the CAISO. These cycles includes over 30 gigawatts of solar generation across the state in solar development regions that include the Tehachapi, Kramer area in San Bernardino County, and Riverside County, of course. The draft plan is proposing to approve 31 transmission projects for a total of 4.8 billion. The increase of low growth is being reflected in these in the most recent low forecast of this plan, right? And this is being driven by building electrification, data center growth, transportation electrification. It's all driving significant reliability-driven needs in this year's transmission plan. For our area, which is I trying to highlight on that green rectangle, this plan is recommending 6 projects for approval for a total of 334 million in new transmission upgrades in the metro and the north of Lugo and the eastern areas where we know significant interconnection interest continues as Scott alluded to. So these projects include short circuit duty mitigation upgrades, advanced reconductoring, and 2 projects to support near-term load growth in the northeast areas from Hesperia along the I-15 and 395. What is one of the challenges we're facing? What is one of the lessons learned from recent most recent plan, right? So one of the primary challenges we're facing is making sure that transmission planning keeps pace with the recent distribution load growth. In some regions, especially those with rapid rural expansion, the gap can create transmission readiness issues, right? So a key consideration is how to account for remote load that is not fully captured in the CEC hyper system peak load forecast, which is what we use, which is an input into the transmission planning process, right? In some cases, especially when studying the reliability of remote load pockets, the known coincidence of station level forecasts may provide a more accurate representation of the electrical needs of these low pocket areas. This map here is trying to illustrate the challenges, particularly in rural areas where the hyper forecast may not fully represent or capture the local growth. This map compares the system level peak forecast with peak distribution in 2026 for the North of Lugo study area. So the polygon with red dots encompasses areas where in San Bernardino, Kern, and Union counties. So the larger the circle, the dot, the larger the load of that area, right? And the colors try to illustrate what are we missing, the discrepancy between the load forecast that we use in transmission planning and the load forecast that we use in distribution system planning, right? So this is this I think highlights, right, the need for a refined methodology, right? One that can integrate local distribution trends into transmission planning more effectively, and that's what we're doing. For starting this year's TPP, we're working very closely with the CEC, with the CPUC, and the CAISO to kind of refine that methodology so we can be, increased readiness of our transmission system, right, for situations like this. Now, you probably have heard of Senate Bill 106 and FERC Order 2023, right? Both of these bills are requiring transmission providers to consider to evaluate grid-enhancing technologies, right? FERC in particular, FERC Order 2023, is more focused on the generation interconnection process. So now we have to, it's not that we didn't do it in the past, right? But it's emphasizing the need to demonstrate and communicate with customers, right? That we are looking at some of these technologies, advanced technologies such as power flow control systems, topology optimizations, for example, to both expand the transmission infrastructure through the transmission planning process and also facilitated connection of generation into our system. So both of these requirements will, from the Senate bill, we have to start reporting to the CAISO, submitting our studies to the CAISO as soon as this year. So our plan is to submit along with our proposals for reliability-driven needs or analysis of gets. And then for the current Q cluster, QC15, we're also going to have to, for quarter 2023, start including that, start considering greenhouse technologies when we try to analyze potential network upgrades that this cluster of generators may need. Let me then transition to the interconnection, the generation interconnection, right? I want to focus on 3 efforts we've been undertaking to strengthen our internal processes so we can minimize the impact on generation interconnection. So first, we launched a work order process improvements. May not mean much for other people outside of SE, but this is a pilot to streamline how emerging projects move our system. So this effort is focused on removing redundant evaluation steps, standardizing project summaries, shifting internal reviews to later stages, all of these to improve both the speed and clarity in project development. So we can start executing on these projects much faster internally, right? The second effort is looking at a long-term advanced procurement strategy, right, to address what we've seen, a significant increase in lead time for major equipment, such as power transformers, circuit breakers, right? So we're trying to leverage multi-year forecasts to secure manufacturing slots in advance so we can proactively mitigate these supply chain risk, right? And we want to improve the alignment between material availability and these project priorities, right? And lastly, we are implementing as well enhancements to our centralized remedial action scheme program. We're doing process refinements, improve coordination. So we have reduced actually the timeline for integrating solar projects, for example, and alleviate some of the backlog. I think just want to conclude this with emphasizing that we are committed to enabling rapid deployment of solar across our system. I think we're trying to advance major infrastructure through the CAISO planning process, trying to support policy changes like FERC 2023 and SB 1006, so we can identify areas where solutions like GETS can help, and continue to improve our internal processes to minimize the impacts on generation interconnection. I think all these transmission barriers are real but solvable, and I think with coordination, funding, sustained commitment, we can address those. So thank you, and I look forward to the discussion.
Well, thank you very much, Manuel. I guess what is evident is that we have a lot of things on our plate, a lot of barriers, potential solutions. I think one of the things that we're trying to do here at the consortium is create a space where stakeholders can collaborate, talk about what their problems are, and maybe how, with membership members and so on, we can solve some of those problems, or at least begin to address them. So again, thank you very much for that presentation. Now we're very pleased to have with us V. John White, co-founder and former executive director for the Center for Energy Efficiency and Renewable Technologies in Sacramento. Over his lengthy career, he's been involved in developing legislation and innovative regulatory programs focused on air quality, renewable energy resources, and the mitigation of global warming. John, I think, has as much knowledge as probably anybody focused on distributed generation issues in California. Please welcome John. He is UC Riverside's 2025 Distinguished Alumnus Award winner. You're muted.
Thank you, Fred, and thanks to Ron Loveridge and his team at CSERT and UC Riverside for putting this very useful forum together. I think what the earlier discussion and presentation suggest is that we have it within our power, as Eduardo Garcia said, to get the grid ready, but it's not yet. And the need that also was mentioned by the Southern California Edison speaker is to coordinate between both the distribution system and the bulk transmission system. But the moment that we're in, the crisis that we face is really affordability. And can we keep rates at a manageable level in a way that will encourage people to use more electricity through electrification of transportation, buildings, and so forth. And that additional can then be used to pay for the cost of building the infrastructure. But these two things have to be coordinated together. At the moment, one of the issues on affordability that we're taking a look at is financing of transmission. There is a wide range of cost associated with building transmission, depending on who's building it and how it's being financed. So under the Federal Energy Regulatory Commission standards, the revenue requirement, which is the amount of money that the transmission owner is entitled to earn, is somewhere north of 13%. Whereas the Los Angeles Department of Water and Power, which is a municipally owned utility, has an interest rate available to it of about 5%. So thinking about how to reduce the financing costs of transmission, potentially by carrying out joint projects or projects initiated by or competitive bid. And EDF Renewables has proposed a project to augment the congestion in the eastern Riverside County area. But getting these transmission projects and the procurement to be aligned is a challenge. The other issue that was mentioned on terms of affordability is battery storage. One of the ironies of a current circumstance is that the cost of maintaining the system reliability, which one of the ways that's done is through resource adequacy, which requires each of the load serving entities to certify that they have procured enough capacity to meet their obligations to provide a portion of the resource adequacy. Resource adequacy, along with wildfire costs, is the fastest growing source of increased rates. And so even though transmission adds costs, transmission ultimately saves money because it reduces the demand for natural gas by using renewables and storage. And that natural gas dependence has to be reduced over time and have the investments needed to achieve those reductions. I think the other issue that is a source of potential local reliability, as Fred suggested, is distributed energy resources, rooftop solar, and also battery storage. But what we now see with solar is that nobody is building a large-scale solar project without batteries. It's just not happening, because the efficiency of being able to deliver power on a more or less full-time basis by combining the battery storage with the solar makes for very good utilization of the transmission. The other thing is that local distributed solar and storage could, if properly compensated, help reduce the cost of keeping the lights on after the sun goes down. We didn't understand fully, the early incentives for solar rooftop were net energy metering, where because the solar is gonna generate more power than is needed over the life of the daily cycle, net metering allows the customer who put the solar on to get paid the retail rate for the surplus solar. Now, they don't get paid in cash, but they get to deduct that rate from what they owe. And there's been concern about this causing a cost shift to other non-solar customers. But if we can find a way to utilize the solar as a reliability tool by paying people to provide storage when we need it in the evening, that can make rooftop solar a very valuable resource. So those are some of the things that we're working on. The other thing that I think is important is that we can't afford to take as much time as we now take approving new transmission projects. California, in the previous administration, didn't approve any new transmission projects by the PUC from 2011 to 2021. And the other problem is that it takes a substantial amount of time, more than we think is necessary, for the PUC to review and approve transmission projects that have been through the CAISO transmission planning process. That planning process on transmission relies on a memorandum of understanding between the Energy Commission, the PUC, and CAISO, and it requires a transmission plan that CAISO develops every year for the next 10 years to use assumptions on what the renewable portfolio would look like provided by the PUC. And so what we are concerned about is if the PUC, once the CAISO adopts a proposed transmission plan, will the PUC decide they want to go back and second guess that determination of need, which will stretch out the approval process. So we're working on legislation with San Diego Gas and Electric that is attempting to streamline that environmental review at the PUC. And there's also other legislation, including a bill, SB 330 by Senator Padilla, that would evaluate alternative transmission financing strategies. So those are some of the things we're working on. And with that, I will leave it at there and see if there are questions.
Thank you, John. Lots of questions. I'm not sure. Okay, so there is a question from an attendee to John Hildebrand. Let's go to that. It seems, John, infrastructure, specifically for renewable energy and the new fire hazard maps conflict. Is there a way to bring infrastructure geared towards renewable energy safely into a moderate to high fire hazard area, or are we not going to be able to build in these areas?
Great question. We're still looking at it, but the short answer is we have to, right? We have to provide opportunities for infrastructure, transmission lines, et cetera, to be built. And it just means a higher level of construction materials, higher mitigation, higher setbacks, fire mods, et cetera. So there's ways to do it. Our fire department is pro-business. They're looking at opportunities to ensure continued development and infrastructure improvements and construction. But we just need to be careful in how we do it and how we approach it to make sure it's all going to work.
Right. Okay. There is a second comment here that I think is worth reading. Rooftop solar provides power where it is needed without the risk or cost of transmission lines. Grid Alternatives, who incidentally will be presenting in our next theme, is one nonprofit that installs solar with the help of resident volunteers. Public buildings, schools, stores, warehouses could all be sites that provide excess power to neighborhoods. Parking lots could be covered with solar, many working examples, and it provides shade as well. Incidentally, there's some good shade solar at CSERT. Some open lots can have solar panels, and gardens can be planted in the spaces. I guess this comment really speaks to the next theme that we've got, which is we need an all-in approach to try to help stand up as much renewable energy as we possibly can. Amongst our panelists, are there questions for Southern Cal Edison or EDF? Just wondering whether there are questions directly for these folks.
Fred, no questions, but if I can comment real quick on the rooftop solar, that's something we do encourage and advocate for as part of our climate action plan. We have an energy reduction requirement for industrial developments, and the way to achieve that is through solar on our rooftops. The other side of that is again, back to the competing interest, right? One of the challenges we have with solar rooftops is in Mead Valley, adjacent to March GAPA. There's this conflict between the light glare into the runway, and then also trying to achieve the reduction of those energies. So we have to very carefully plan on where those solars can go on those rooftops out there. It has to be run through the Airport Land Use Commission to make sure that's going to work correctly. So back to those two issues again, and a lot of older buildings would need to be retrofitted to support the weight and electrical of these rooftop solars, which can be done, but there's a cost prohibition and some barriers to achieve that sometimes.
Well, thank you for that. Seeing that there are no further questions, let's move on in the conference. The next theme in the conference is focused on community solar, a topic that is particular importance in California these days. Our first presenter for this panel is Dr. Alfredo Martinez Morales, the managing director of the Southern California Research Initiative for Solar Energy. He's a research professor at the Center for Environmental Research and Technology at UCR, and he also happens to be a co-chair of the Solar Valley Consortium along with Ron Loveridge. Alfredo, please take it away.
Thank you, Fred.
He'll help set community solar in context.
Yeah. Can you see my screen and hear me fine?
Yes.
Excellent. Okay, well, let me start by first providing a simple definition for community solar. In very simple terms, it is a shared solar project where multiple participants benefit from a single solar array. The main value proposition is that it's an inclusive approach because it allows access to clean energy for renters that don't own the roof, low-income households that may not have the financial resources to have solar, and to those that don't have a viable rooftop. So I think community solar provides a very interesting opportunity for those who don't have the direct opportunity to have their own system. As of June of 2024, NREL reported that community solar projects are located in 44 states, including the District of Columbia. 23 states have policies that support directly community solar. And we can see that in terms of the community solar projects nationwide represent about 7,800 megawatt of AC generation capacity that has been installed. Now, there are two concepts that I would like to use as framing concepts. The first one is that we have to acknowledge the reality of community solar, right? So as I said, I was able to describe it in very simple terms. And so it is an easy concept, but it is a hard reality to implement. There are multiple challenges why this is the case, but particularly you have to navigate hurdles through policy and regulation. There are very long grid interconnection delays. The cost recovery sometimes is not very clear. And also the benefit sharing models need some improvements. Now, despite the fact that California is a leader in terms of solar, it does continue to struggle to deploy community solar at a significant or a meaningful scale. The second concept is this idea of community solar plus, right? So it is an emerging solution that goes beyond bill credits. So basically, it provides economic inclusion through taking advantage of multiple areas of opportunity. So for example, workforce development, local supply chain stimulation that also leads to local economic activity, community ownership stakes or revenue sharing for those who participate in the program, and the integration with resiliency and equity planning, right? So all of these areas provide opportunity for evolving community solar into community solar plus. So what is the current state of community solar in the state of California? Well, as I said, California leads the nation in overall solar deployment. There has been 49 gigawatts installed, which represents about 31% of our electricity generation. Approximately 160 megawatts have been deployed in California through community solar projects, through specifically taking advantage of programs like the DAC GT and the CSGT, which have been policies that have been critical to enable the deployment of these 160 megawatts. But when we look at 160 megawatts in comparison to 49 gigawatts, it's a very small amount, right? So it's about a third of 1% of the generation. So certainly there's big opportunity, and we need to overcome the existing challenges. Now, again, challenges, it's a large multitude of issues, but the processes are cumbersome. There's limited ability to scale the programs. The programs are pretty fragmented. Also, because there are constraints at the grid level, there's a need to work closely with utility companies, which in some cases slows things down, right? Because they have to comply with regulation, and the projects have to meet also, the different rules for interconnection. So all of this creates, several challenges in the implementation of a community solar project. Now, fortunately, in California, we have policies like AB 2316, which mandates 51% low-income share in terms of participation, provides alignment with being compliant with Title 24, but also took the CSGT and the DACGT and kind of, mold them into a program that allow for expansion. There are some success stories at the state level for community solar projects. In fact, there is a project of approximately 1 megawatt with the Santa Rosa, Bano, Coahuila Indians that was led by Grid Alternatives. And this project in particular, provides clean power and benefits to 238 families. About, I believe 38 of those families are residents of, the tribe, and 200 other families that are part of the distribution system get to benefit from this project. Thinking about what would it take for community solar to become more successful in California, we can look other cases in other states. If we take a look at what is going on at the national level, we can see that states like Minnesota, New York, Illinois, Colorado are the leading states with regards to the deployment of community solar. When we look at the key to success across these four top performers, we can see that there are some characteristics that make them quite viable. So there's a strong mandates and statewide targets that are well defined. The tariffs are already standardized, and also there's the bill credits are very clear. The programs are designed in a way that allow and encourage the third-party market participation, right, and access. So I think there's already good examples that California can continue to look at more closely. So California has already looked at some of these successful programs and has made adjustments to what's been implemented here at the state, but there could be a further opportunity to look more closely at these case studies. For example, in the case of Minnesota, it was the program Community Solar Garden was launched in 2013. At the beginning, it was an uncapped program with that was being driven by developers, and was able to achieve over 900 megawatts of growth using a fair bill credit approach. But in its initial implementation, it lacked equity for low income, medium income participants. And so just like many things in life, if not everything, in order for things to thrive and to growth, there has to be some level of adjustment. So in 2024, the administration for this program changed from Xcel Energy to the state. And also the program started to implement, some level of caps. So for example, for the time frame of 2024 to 2026, there is 100 megawatt, per year cap that, over time will continue to decrease in order to manage, the interconnection and the management of those systems. It does, in this newer, modification of the program, 55% of the low income, medium income participation, it's mandated. And there is a minimum of 25 subscribers per megawatt of capacity, but also no single subscriber can have more than 40%. So all of these, adjustments that have been made to the program are the result of the success that they experienced, but also some of the things they understood could be improved, right? Although this program has been successful from the perspective of community solar developers, potentially could end on July 2028 as it may go through the legislation. Okay, so coming back to California, we can take an approach to do a strength, weakness, opportunity, threats analysis. So in terms of the strengths, as I mentioned, California leads the way nationwide when it comes to solar deployment, right? So we have a very experienced industry. We have, lots of community support. We understand what are the benefits in terms of economic, environmental, equity. And also we have very strong equity mandates for energy justice and just transition, including, SB 535, AB 1550, SB 100. So all of these different mandates can be a great framework from which, community solar at the state level can grow in a sustainable manner. We also have supportive legislative and regulatory momentum. So there's recent laws like AB 2316 and the recent decision by the CPUC 24-05 -065, they do provide new frameworks for inclusive community solar programs. Additionally, we also have some very good implementation tools. For example, virtual net energy metering, the SOMA project, and the existence of the CCAs throughout the state can support rapid project design and customer enrollment. Furthermore, there's already a pretty strong infrastructure for community engagements. Grid alternatives, as it was mentioned by one of the attendees and also will be presented shortly, have been an extremely active, nonprofit at the state level. And in fact, my group, CSERT as a center, over the years has had multiple projects with grid alternatives. And shortly, I'm going to be highlighting one of those projects as I continue to discuss the concept of community solar plus. In terms of the weaknesses, interconnection bottlenecks are, fairly, a high weakness. The timelines are lengthy, sometimes very uncertain how many years a project can, take in order to be interconnected. In the best of scenarios, could be 1 to 2 years, and the worst can be 4 years, or at least that's what we have seen in some of the projects that we have been involved with. Permitting and land use complexity complicates things. Zoning, CEQA, not in my backyard concerns, they do increase, they have a tendency to increase these project timelines, and also to increase the cost for the development in many of the jurisdictions that we have in the state. The programs also have suffered from the issue of fragmentation and complexity. Things, they're not quite working together well. And also because they are so complex in some instances, they do not allow for participation by some of the interested parties. Financial uncertainty, it's another challenge because it makes investors cautious about participating in some of these programs. And so there is a perceived high level of risk in some of these projects. And California being, well, such a large economy, we know that there's a tendency for cost in California because of salaries and the cost of goods and the cost of living, other things. So there's certainly, a higher project soft cost when compared to other states. For the opportunities, the opportunity to integrate resiliency as part of the projects. It was already commented that new solar should have battery. That batteries provide a large multitude of services and value to the grid at the distribution, at the transmission level. Opportunities for local workforce and economic development, right? So we know that California now, if we were to be a country, we will be the 4th largest economy in the world. I think that those emphasize the need to continue to have good economic growth. And so workforce development and economic stimulating the local economy is extremely important. Leveraging the existence of the CCAs, another aspect that could be significantly leveraged, and the synergy with grid, modernizing the grid. Being such an active state, certainly we have projections that the energy demand will increase because of electrification, of EVs, of even as a result of some of the climate events that we're experiencing, right? So there's certainly an opportunity to modernize the grid And then we have already in existence a multitude of partnerships across all sectors, right? And so all of these provide various opportunities. Now, in terms of the threats, there are volatile policy signals. For example, NAME 3.0 created quite a bit of disrupt in the industry, particularly at the residential level, right? We have heard stories of companies having to slow down and, let people go. And so I think, some of these policies can have significant impact on the success of things like community solar. There is a high need for utility alignment. Community solar must complement the goals by the utilities to gain support and also to avoid potential conflicts, right? So we heard from SCE, from Manuel, that SCE supports the development of solar, and I think there's opportunity to further continue collaboration and involvement, and so everybody, I think we all have to align our independent goals in a manner that allows for some of that alignment and collaboration to continue. There are some gaps in the trust by the public. That is a threat that I believe Grid Alternatives is quite familiar with. In some cases, people are reluctant to participate in programs because they don't believe that things can be as good as having a solar system installed at your home at no cost, right? So there's quite a bit of work that we need to do in terms of having higher trust by the public. And something like, for example, the potential reversals, right, or the current reversals in terms of federal policy, right? So under the current administration, it's unknown, or at least there's no certainty what's going to happen with some of those, IRA-driven projects, right? So that or the funding that was promised or that was used for some of the projects that are currently being developed. So I wanted to come back to this idea of the Community Solar Plus, and I wanted to highlight this project that we have ongoing in the city of Long Beach. We are hopefully 2 weeks to receive PTO on the solar component of the project, and hopefully within a small number of months, 2-3 months, we can have PTO on the battery. But the facility, the Spark Midtown in Long Beach, is a multi-use facility. It falls within the 91% 100 called Enviro Screen 4.0 results. It is a low-income multifamily housing with 95 units, a combination of 1 room, 2 room, 3 room to accommodate different family sizes. But something that makes this project quite unique is that 50% of the residents are, formerly homeless, right? It is a facility that has a LEED Gold certification, and it's a fairly large facility, 12,388 square feet, including multiple tenants, YMCA Youth Institute, a communal kitchen for workforce training, and also education on eating healthy, and a medical center health clinic, right? So this is located in Long Beach. And some of the things that make this project quite interesting in terms of the community solar plus concept, right, is that it can be used as a form of a strategic leverage. So the project has a solar plus storage for the facility. It's taking advantage, or it provides benefits to the tenants through virtual net metering. It has the unique characteristics that the solar PV system is interconnected in front of the meter, whereas the battery system is connected behind the meter. And the battery is only charged from the solar when there is a power outage to support some of the public tenant areas. In terms of the financials, is accessing SOMA and CEC EPIC funds, and also SGIP funds, right? So this project leverages a research partnership between the university and the facility. It's leveraging public and public, private and public funding. It's leading to opportunities in terms of job training, co-location with services, community engagement, education, and outreach, right? So I think these kind of projects where you go beyond the bill credits, but you provide resiliency and a series of benefits to these multi-use facilities. I think that's something that is it's very interesting to be able to do as a university, because ultimately the benefit that we see from these type of projects funded by the CEC is that these can create scalable, replicable models that can lead to structural change. So in terms of the key takeaways, community solar must be or must have center equity through co-design. It should leverage storage, EVs, allow for implementing resiliency hubs. Also must involve different sectors: housing, public health, education, social services. And for planners, regulators, and funders, we need to be able to cut some of these soft costs by simplifying interconnection and processes and making very clear what are the economic financial benefits, not only to the owner of the system, but to the tenants and also to the potential investors, right? So, and we have to, in general, broaden definition of community benefits, right? Because it's not just the energy and it's not just the dollars, but having a clinic on site, having a program where young people can be after school, having the opportunity to learn how to eat healthy. I think it creates a latitude of opportunity and basically expands this community solar concept quite dramatically. So to conclude, we have to be careful to avoid poison pills. Unfortunately, subtle fees or overly strict rules have a tendency to deter participation. And from experience in other states, we know that simplicity and certainty are key for a successful program, right? We want to make the process easy for people to subscribe. We want to be able to guarantee savings, and we want to make the revenue model attractive enough for investors so that we can draw in capital. With that, Fred, I will be happy to respond or to answer questions at the end of the session. Thank you.
Thanks very much, Alfredo. Really great overview. Next up, we have Joel Danforth, Senior Director of Equitable Community Solar for Grid Alternatives. Joel has over 10 years of experience in distributed energy research and deployment. Prior to Grid Alternatives, he worked at the U.S. Department of Energy. He's also worked at Platte River Power Authority and as a power plant analyst at Ventix. Please take it away, Joel.
Thank you, Fred. Hopefully everyone can see my screen here. I'll try and get this into full screen mode for everyone. Thank you, Alfredo, for the wonderful presentation and introduction to the topic of community solar. Once again, I'm Joel Danforth, Senior Director at Equitable Community Solar with Grid Alternatives. I am not a Californian. I reside in northern Colorado, but I wanted to wish all the Californians on the call happy May Day. For those of you not familiar with Grid Alternatives, we are a 501c3 nonprofit organization. we specialize in providing solar services to low-income and disadvantaged communities nationwide. Last year, we celebrated our 20th year in operation. So we've been around a while, and we're growing really strong. When we talk about the topic of communities specifically, and how community solar can help address some of the energy issues faced by low-income and disadvantaged communities, an important consideration is energy burden. Some of you are familiar with the term. According to the Department of Energy, energy burden is defined as the percentage of gross household income spent on energy costs. And that is something that we really want to be laser focused on. Also, according to the Department of Energy, low-income households on average spend as much as 3 times of their annual income on energy costs compared to non-low-income households throughout the nation. So you can see that that's a significant additional burden for those low-income and disadvantaged communities. So having framed the issue, I wanted to spend some time today talking a bit about some of the tactical approaches that we look at in terms of addressing the issue of energy burden for low-income and disadvantaged communities. Some of which, as Alfredo already shared in his presentation, include the following. With community solar in particular, one of the advantages that we look at is no upfront costs to the consumer. Some of you familiar with some of the older community solar models might be acquainted with the capacity model, where it's essentially behaves like if you had purchased solar directly. You pay the upfront cost of that energy, and then over time you get a payback period for the energy, the value of the energy that accrues. The industry by and large has moved away from that model, and I'll come back to that here in a moment. It's primarily an energy model, dominant industry for community solar, and that does have the benefit of reducing upfront costs to consumers. When we talk about low-income and disadvantaged communities, we also want community solar to be portable. And what I mean by that is we want it to your subscription to be something that can move with you as you relocate within your utility service territory. So oftentimes when we're looking at low-income disadvantaged communities, renters are predominant. And as was mentioned in one of the previous presentations, community solar is a wonderful solution for renters in particular. To make community solar subscriptions portable, we like to work with the utilities on that. Most utility billing systems have a location ID that sticks with a physical address, a meter ID that sticks with a meter, no matter where that meter is moved, and an account ID that sticks with an individual. We like to associate our community solar subscriptions with an account ID so that it goes with that consumer, regardless of where they move or what happens to their meter on site. So that's really what I mean by portable. And then incremental, by incremental, I mean we can adjust to any percentage of the subscriber's annual electricity usage, up to 100%, and in some states over 100%, 120%. Here in Colorado, they recently lifted that cap up to 200% of annual usage that can be met through solar generation. But we can also adjust downward to meet the billing needs of the consumer. So that's what I mean by incremental. The next tactic that we look at in terms of community solar is leveraging economies of scale. Most everyone's familiar with the concept. The data here is from 2024 from the Solar Energy Industries Association. But you can see that the typical rooftop solar installation in 2024 cost of consuming about $3.25 per watt. Commercial scale came in at about $1.46 per watt, and utility scale at $1.08 per watt. So the obvious answer is, as we're able to shift scale to the right and build larger installations, we're able to drive down the cost per unit of energy and pass those savings along to the community solar subscriber. Now, one of the trends that we are observing in the industry right now is some of the effects of the Inflation Reduction Act and the grant activity that was generated through that. Wonderful investments in inflation reduction, I'll come back to that, and in renewables in particular. Some of the counter trends to that are requirements within the grants for prevailing wages and for American manufactured equipment, both of which do have the effect of increasing these price points a little bit across the board, regardless of scale that you're looking at, but with good purpose. We want to make sure that people working within the solar industry are paid at a fair wage and that they are receiving fringe benefits that are appropriate to their line of work. And we also want to ensure that there's a robust growth in local manufacturing of solar equipment. So these are all good things. These are all good trends. It is a bit of an adjustment with modern tariffs as well, playing a role in that also. But we think that the long-term prognosis for solar and for community solar in particular is bright. It's looking good. These costs will adjust and normalize with time. So I mentioned the levelized cost of energy on the first slide, and that's really the main change from the historic capacity models observed in community solar. So by taking the cost of the project, levelizing it over time, over the life of the asset on a pennies per kilowatt hour basis, we're able to remove the upfront costs of the solar so that there is not that barrier to entry to a low income or disadvantaged community subscriber. And instead, what they see on their bill is a percentage savings on that bill, as opposed to a upfront cost with a payback period over 7 years or so. The savings are immediate and effective. So here in this example, I just took one of those SEIA data points from the previous slide, and I levelized that over a 20-year assumed life of an installation, such as commercial installation. And the cost of that commercial scale project levelizes to about 6.7 pennies per kilowatt hour. So there is an opportunity to immediately impact utility bill, where this levelized cost of solar energy is lower than the retail rate observed at the utility. This final bullet point on the right-hand side of the screen shows the national average for utility rates per kilowatt hour, and that is 16.88 cents per kilowatt hour. And if you subtract from that the levelized cost of solar energy, you can see that there is a significant annual bill savings for the national average numbers there of about $1,000 per year for utility bill savings. Now there are other components that are baked into that cost, the cost of subscribing the energy, and the long-term O&M costs that should also be incorporated into the levelized cost of energy. But this serves as a good example of some of the potential savings that we want to capture and convey onto the low-income communities. A couple of things on working with the utility, and this was certainly addressed in the previous panel section, but those interconnection costs can be costly, and we want to be aware of that. We want to partner with the utilities and be good partners for the utility on identifying points of interconnection and finding reasonable costs for interconnecting with the grid for community. Also, we like to work with the utilities on the bill credit mechanism for taking the value of that energy, applying it as a credit on the bill of that low-income subscriber, and making sure that they are receiving that benefit. Here in Colorado, they recently introduced consolidated billing such that community solar subscriptions are incorporated into the billing system of the utility itself. So rather than having a third party administer the billing process for community solar, it's all handled through the utility as well. Same as they would pay for some energy directly from elsewhere on the grid. One thing that I would be remiss not to mention is in cases of community solar sited directly on the distribution grid within the community is intended to serve, we would like to see utilities not apply a transmission rate or a transmission cost as an unavoided cost for that energy for low-income communities. The result of that situation where a community solar installation is sited within a low-income community, but they also have to pay a transmission fee or rate on top of their bill credit that they are allotted, that becomes a reverse subsidy. It becomes the low-income community paying a little bit extra on their bill or seeing a little bit less benefit from their community solar credit to subsidize the cost of transmission outside of their distribution grid. So that is one area that we'd like to work with utilities on improving upon for the long-term viability of community solar in the States. One of the last things I will mention is solar as a hedge against inflation. So it's no secret that there is concern about inflationary pressures here in the United States here recently, and community solar in particular, with the levelized cost of energy, poses a wonderful opportunity to hedge against that inflation. In certain community solar business models, they sometimes include a rate escalator within that levelized cost of energy. My personal philosophy is don't do that. Let's give people the opportunity to lock in their energy rate for the long term and give them the opportunity to recognize savings over time. The graph here displays EIA data on the average utility retail rate over time. And like everything else, there was that COVID-related spike in inflation in the early 2020s. That is that inflection point, the rate of increase in utility rates. But for those who had invested in community solar previously and had the opportunity to lock in that rate, they had a hedge against that inflation spike. The cost of their solar energy, our community solar energy subscription, remained flat during that time. And that's really what we want to see for consumers, low income and disadvantaged communities in particular. As a grid alternatives representative, I would be remiss if I did not mention workforce development. Labor shortages are one of the industry-wide concerns that we are observing. Having boots on the ground capable of installing racking and connecting panels and even master electricians to do the wiring. And Grid Alternatives is uniquely positioned to help address that. We think that the disadvantaged and low-income communities that we serve are a wonderful pool of labor to help construct solar projects and provide those benefits directly to the communities, those same low-income and disadvantaged communities. And to that end, Grid Alternatives does offer a couple of workforce development programs, one with 120 hours of in-classroom curriculum, and one with 200 hours of in-classroom curriculum. And we also provide that hands-on experience that Grid Alternatives is known for providing to communities that we serve. And we are looking to build upon that wonderful history of workforce development moving into the future, with an eye towards the low-income and disadvantaged communities. So that is it. I will leave it there. That's my time. Gridalternatives.org, that is our website. If you'd like to, if you're not familiar with us, you want to check out our work and the things that we do. And I'll pass it back to you, Fred. Thanks.
Thanks a lot, Joel. Great presentation. And I would also like to say that as a number of us have watched Grid Alternatives grow over the last decade or so, 5 years in particular, we're very impressed by the way you have been able to serve underserved populations. So many kudos for that. Next up, we have Charles Loudon with us, Legislative Director for California Assembly Member Chris Ward. Charles was featured on a previous Solar Valley webinar that was focused on community solar, and he and Assemblymember Ward have introduced legislation to boost the adoption of community solar in California. Please welcome Charles. Charles, we'd love to hear how you're doing these days.
Yeah, thank you so much. Like Fred said, my name is Charles Loudon, Legislative Director for Assemblymember Christopher Ward, representing the 78th Assembly District here in California that mostly contains a large portion of San Diego and a little bit of El Cajon, which we know is a huge solar market, a lot of solar owners down there. So it's something that my boss hears all the time from our constituency. We want to make sure that we're promoting solar adoption where we can, and also making sure that we can get as many people into solar as possible, because we know the benefits can be really, really helpful for people in their energy costs. So a little background, my boss got into community solar back in 2022. He introduced AB 2316, which has been mentioned a couple times on this webinar. That really asked the Public Utilities Commission to look at all the programs we have on community solar, consolidates the ones that we have, and create a new community solar program that really addressed a lot of the issues that we were hoping to solve. During that process, we strongly supported the net value billing tariff that was supported by a lot of the supporters that 2316 had. And unfortunately, during that process, the Public Utilities Commission decided to go with a different proposal that we see as having some issues and some things that may stop the program from being viable long-term. So this year we introduced AB 1260, which makes some key changes to make sure that the CREP program, which is the one that they adopted, will really realize a lot of the benefits that we wanted to see. Specifically, we want to make sure that program supports the adoption of clean energy in the development of new housing. So make sure that it complies with Title 24, gives a kind of lower cost alternative to rooftop solar where it doesn't make sense, and make sure that we can build all the housing that California needs while still meeting the renewable energy goals that we've set. We also want to make sure that we keep the requirement that 51% of the subscribers to the program are low income. We feel like that's a huge goal for the bill, because a huge portion of California can't adopt rooftop solar. They're either renters, they don't have houses that can put solar on top, or they just don't live in an area where it makes sense. So we want to make sure that we bring in more people that currently are locked out of solar benefits. We also want to make sure that we're minimizing impacts to non-subscribers. That's one thing that we've heard a lot this year, but also in years past. The cost shift argument is something that we're hearing a lot from members right now with inflation being the way it is, with tariffs. I think most of our constituents are feeling some kind of cost pressures in their life. So we want to make sure that we're very sensitive to that. We believe very strongly that if you set up a community solar program like the one that we've outlined in 1260, that there will be benefits not just to ratepayers, but to all Californians. And then part of that, we also want to make sure that this program can benefit people up and down the state. My boss represents a highly urbanized district. However, we've been in touch with a lot of rural members in the Central Valley. We've been talking with farmers to make sure that they can realize those benefits. One thing we've seen in the last couple of years, unfortunately, with the added cost burdens is a lot of fallowing of land, a lot of farmers having to make very tough decisions. And we want to make sure that they can benefit from this program and maybe utilize part of their land that they otherwise can't use for farming and get some direct benefits back. One thing that we've been that we put together to make sure we can kind of push the idea of the benefits, we worked with Aurora research to put out a study that kind of will show the benefits of community solar, not just to the ratepayers, but to all Californians, and also show the benefits that it can have on the grid. So I don't want to talk too long because I know there's a lot of very smart people on the call. I'm more of somebody who kind of helps get things to the legislature, but this is something that my boss feels very strongly about, and we really want to make sure that we have a robust community solar program in California and one that can last long term. So thank you.
Okay, Charles, do you think that what likelihood do you see to being able to get that new bill through?
Yeah, we think that it's to get through the legislature, we think it's very likely. We were able to get a lot of support back in 2022 to push for this type of a program. I think we're in a much different area setting than we were back then. I think there was a lot of conversation about letting it go through the process, letting it go through the CPUC, making sure that they can evaluate the program and come up with the program they want. We feel like we were able to allow the CPUC to go through that process. We have some things that we feel are needed changes in order to make sure that their program achieves the goals that we originally set out to achieve. And so we've been working with a lot of members to make sure that they understand the benefits for that. We also have a larger coalition than we did back in 2022. Back in 2022, we had a then unprecedented kind of coalition of enviro groups, labor groups, developers, both on the housing side and on the solar side, as well as ratepayer advocacy groups. Those groups don't always agree on everything, and we felt very strongly that bringing them together and bringing them to the table would create a very polished product. Now we have also brought in some of the agricultural groups, some of the Central Valley groups to make sure that this is not just a great coalition, but it's also a statewide coalition. And so we feel very strongly that we can get it through the legislature. We're working with the utilities and the CPUC to help kind of address some of the concerns that they've brought to us, as well as working with the governor's office to make sure that we get them the information that we've been able to collect over the last couple of years.
So could you comment on, because one of the things that I recall from a previous round of discussions was the desire to fund the program in a robust way, I guess would be can you make a comment on that?
Yeah, back in 2022, we were obviously in a different place than we are now. I think there was a lot more hope that we can get state and federal funding into the program and we can kind of help supercharge it at the start. I think we were still very confident that we wanted to make sure that the benefits that were given to the projects and the ratepayers were still robust enough that the program could stand up on its own. One thing that I think we had some disagreements with the CPUC was at what rate are we compensating that energy The CPUC wanted to use the federal wholesale rate, which we felt was inappropriate. We felt like we wanted to use the avoided cost calculator. It's something that the PUC created for these types of programs for rooftop solar. And so when they did their cost analysis for cost shift, they took the difference between those two calculators and used it as the cost shift. We've been very upfront that we felt like that was not appropriate, that we feel like we need to take a larger look at the benefits to not just ratepayers, but also to the grid as a whole. That was part of the reason why we put together the Aurora study that just came out in April, that really shows the benefit that it could have for all Californians and help kind of achieve our goals in a good manner. And part of that was also to make sure that now in 2025, that this program can stand up on its own. We don't know what the state budget is going to look like in the next 10 years. It's not looking great right now, so we want to make sure that we're being realistic. And there's a lot of uncertainty at the federal level of what kind of funding we're going to get. So we want to make sure that any program that we create is not only viable at the start, but will actually be able to be here long term, because that's the overall goal for community solar in California.
Right. Okay. Thank you for that. I will mention that in our next theme, we have Jocelyn Fairbairn with us, who is a representative from Luminia, a community solar developer. So we'll hear from the developer's point of view as well. Are there questions for this panel?
I saw Jacqueline said wanted me to speak on the timing of the bill. I can go ahead and do that now. So right now,
Please.
the bill just passed its first big hurdle. So we just got through the Utilities Committee in the State Assembly. We took a few amendments to help kind of address some of the concerns we heard from members, and those are mostly reporting amendments to make sure that if and when this bill gets passed and implemented, we can have a study done 2 years after the program starts to make sure that we are providing the benefits that we say that it will provide. So now the bill is going to the Appropriations Committee, which we all know is a bit of a black box, but we're working directly with the chair of Appropriations, who's been a supporter in the past. We want to make sure that she understands what the updated bill does and kind of our responses to the concerns. And then the bill will go to the Senate, where it will most likely not be approved ultimately until around August. And then it would go into effect in January. But our hope would be that if we can get it approved in August and signed by the governor, then we can start implementation right away, given some of the mandates in the bill.
Okay, thank you very much for that. All right. Our next theme captures the notion that we really need an all hands on deck approach to solar and storage in California if we're going to get even close to meeting California's clean energy targets. There are some sort of innovative ways to look at this, and one of them comes from a company called Sunrun. Our first presenter in the all-in theme is Yang Yu, Director of Virtual Power Plant Development for Sunrun, formerly focused on residential solar, now focused on residential energy storage and virtual power plant development. He is grid services strategist, distributed energy resources expert, and I will note a passionate clean energy advocate. Yang will focus on virtual power plant activities at Sunrun. Please take it away, Yang.
Thank you, Fred. Can everyone hear me? Great. I know the topic is going to talk about residential solar, but I want to use the next 10 minutes to pivot a little bit to virtual power plant as the grid or solar gets saturated during the middle of the day. It's important to pair residential solar with storage to increase the value to the customer and also increase or enhance the grid services value to the distribution grid. Just a quick introduction about myself. My name is Yang Yu. I'm the Director of Business Development from Sunrun Grid Services team. So I'm primarily responsible for market strategy and program development for our battery VPP fleet, primarily focused on California and Hawaii market. Sunrun is the largest residential solar and battery provider in the country. We pioneer solar as a service subscription model back in 2007, and we have over 1 million customers right now nationwide, and that represents 7.5 gigawatt of solar. And 3 years ago, we repositioned ourselves as storage-first company. Now we have over 150,000 batteries deployed across the country, and that is about 2.5 gigawatt hour of storage capacity. And now we are responsible for nearly half of all new residential battery deployment in the country. So sitting on this massive solar and battery fleet, we are the largest residential battery VPP aggregator in the country as well. I know some of you may hear all the press release in this industry. We are still in the pilot phase to test out virtual power plant, but I think from our perspective, we are way over pilot phase and we are operating VPP at scale in many markets. So in terms of virtual power plant, one major difference between traditional demand response and virtual power plant is VPP focus more on behind meter generation, so such as behind meter storage or some of the vehicle like V2G capabilities. So basically, VPP is using software to dispatch a fleet of assets such as storage, EV, thermostat to deliver similar, if not identical, grid services compared to utility scale generation. And in terms of like what is the role of VPPs in addressing load growth? I think first of all, the most advantage from VPP is it is fast and scalable capacity solution. So if utility want to build a new gas peaker plant, usually that takes multiple years. And sometimes it's even longer if there's an interconnection delay. A VPP can be stood up in months by enrolling existing asset to deliver grid services to the grid. So we have our first partnership with PG&E back in 2023. It took us 6 months to launch the program from contract signing. And second, I think VPP also provide or defer, VPP can defer distribution infrastructure upgrade. So utility typically need to build either new power plant or upgrade existing distribution line or expand substation to support this new load. VPP, again, can tap into existing DERs to create this new capacity, deferring or avoiding the needs of those distribution infrastructure upgrade needs, create savings for our ratepayers. And in terms of the affordability benefits of virtual power plant, first of all, it lowers the energy bill for all the participants. So usually when we recruit our customer, put them into the virtual power plant, we provide a direct compensation to award their VPP enrollment and participation. Customers can use those payments to lower their energy bills. And on top of that, virtual power plant also create a cheaper grid for everyone else. I mentioned, VPP can avoid or delay infrastructure upgrade. It also provides grid services such as, peak load management or some of the other like frequency response, other grid services use cases. So all of this lower the energy cost for all of the ratepayers. Plus, when you have a batteries, it's also enhance grid resiliency without a big cost. Where we are in terms of virtual power plant in California, speaking from Sunrun experience, right now we have basically 3 different programs in the state of California. The first one we name as CalReady virtual power plant program. It is a statewide program eligible for all IOU customers. So CalReady is our customer-facing program name. It is a CEC demand-side grid support program. It is a state legislative funded program by CEC to dispatch behind-meter generation during grid emergency event. Last year, 2024, we had 16,000 customers participate. And this year, we actually today is the first day of the program season, and we actually just put out a press release. We have over 56,000 customers, 75,000 batteries enrolled in this summer, and we forecast our capacity performance is going to be somewhere over 250 megawatt. Again, like we are already at a large scale operating virtual power plant, basically providing the same scale capacity compared to a utility scale generation. So on top of the statewide program, we also launched our second partnership with PG&E this summer to look at a distribution relief virtual power plant. So instead of focus on bulk system peak load reduction, this distribution VPP tap into existing asset sitting behind constrained distribution feeders or substation, using those batteries to deliver local level peak load, peak demand relief. And the ultimate goal of this approach is for utility to tap into DERs as a tool to deferral or avoid distribution upgrade needs, create savings for our ratepayers. On top of that, there are some other programs with community choice aggregation. So as a CCA, they have obligation to procure capacity to satisfy their resource adequacy obligation. So instead of contracting with utility scale generation to provide RA, they can also tap into residential DER to provide the same capacity needs. But there's some challenge to operate this asset in the CAISO market to provide resource adequacy. That's why we are doing demand side load modifying product to the CCA to provide resource adequacy needs. So I think that the last topics I want to address today, maybe just to focus on what are the challenge or opportunities in California in terms of virtual power plants. As I mentioned, one of the challenge I think lives in the CAISO market. Definitely, if every single DER can be wholesale market integrated from a grid planning perspective, CAISO will have more visibility into DER operations. This increased visibility will create more transparency for CAISO in terms of system planning. But significant challenge exists in the CAISO market to effectively allow residential DER to be wholesale market integrated product. So right now, there is a policy working group at the CAISO to solve this challenge. It's going to be a long process. It takes multiple years. And I'm not super positive there's going to be enough changes made in the tariff to remove all those barriers and create effective pathway for DER to participate. Even all of the challenge are resolved, we won't be able to participate until Q1 2027. And I think next, maybe the next challenge is around policy support. So I mentioned the CEC Demand Side Grid Support Program. It is a great program, and the program success speaks for itself. This program was just launched in 2022, and the first year there was only a few megawatt enrolled, and last year it's a few hundred megawatt of capacity enrolled in the program, and this year we are even tripling that numbers from 7 perspective. A great program, and CEC really took the leadership to create this program. But again, for this program, every year we are facing a run of change in terms of program guideline. If you are sitting from the customer perspective, customer requires certainty. Like they don't want to change, they don't want a program to change year over year. They want to know how my battery is actually being operated for VPP year over year. So we need a long-term program certainty to make sure customer understand the program and actually stay in the program for multiple years to provide great services with their devices. And on top of that, program funding is also a huge risk. So right now, like we are confident we have enough budget to run this program for this year. But again, we don't know if there's enough budget for this program to run next year or in 2026. If I have to go back to the customer every single year to tell them, oh, this program becomes available again, do you want to participate? The customer acquisition cost is really high. We talk about affordability. One way to create affordability to our repairs is reduce customer acquisition cost to put them into a virtual power plant program. So if I have a 5 years program certainty from budget perspective, I can enroll that customer in 5 years as a whole, rather than every single year I have to create sales and marketing, reaching out to the customer, and then provide them a different incentive to ask them to enroll in the program. So policy or regulatory support is really important to continue scaling virtual power plants in California. I think I'm about well over time, so I'm going to stop here and happy to answer any questions. Thank you.
Well, thank you very much, Yank. The first question that I have is where are you finding budgetary support?
I do not know. I think this is more a policy or regulatory question. Again, I think right now it's a little bit sensitive to tap into ratepayer funding, given affordability is a huge concern. But again, VPP is a cost-effective tool to lower the bill for our ratepayers. So I think from CEC or CPUC perspective, we need to create different pathways to tap into VPP capabilities to tap into this asset, provide grid services to the grid to lower the energy costs for our repairs.
Yeah. Okay, that's great. Thank you. So we've just heard about virtual power plant development, where in this case, 1 million customers can be integrated into a single program, a small scale. Next, though, we're going to be hearing from Marissa Mitchell from Intersect Power, who is going to be talking about large-scale solar. Marissa, again, is no stranger to our webinars and conferences here at Solar Valley. She leads land use planning, community engagement, and environmental policy for Intersect Power. Her focus is on minimizing environmental impacts and maximizing environmental enhancements. I love that focus. She has a wealth of experience, and if we're lucky, she might say a word or two about Intersect's recent deal with Google. Please welcome Marissa Mitchell.
Thanks so much, Fred and Ron and the others involved in putting this conference together. It's always a nice mix of folks across the industry coming together to share ideas. So again, as Fred mentioned, I'm Marissa Mitchell. I'm head of environmental and permitting with Intersect Power, which is a clean infrastructure development company and also one of California's largest independent power producers. We currently operate about 1.4 gigawatts of solar and a gigawatt hour of battery storage in the state. And then in our near-term pipeline, we have another 4 gigawatts of solar and 8 gigawatt hours of battery storage in late-stage development. And these projects are scheduled to come online in 2027 and 2028 in the state. So when Fred mentioned the topic I'd be speaking about today was about an all-in approach, I immediately decided I wanted to talk about how important it is to integrate solar across all sectors of the economy. And I think doing this, the best way to do this is to kind of step back to characterize the arithmetic, the carbon arithmetic problem. And so I'm going to be doing this just really quickly in a not a very beautiful slide, so forgive the way my slide looks here, and I'll just have it up for a couple of minutes here. But and this is economy-wide. So across the entire US economy, this is not specific to California. The numbers differ slightly for California. But economy-wide in the US, the manufacturing sector results in about 1/3 of domestic carbon emissions. The electricity sector represents about 1/4 of emission. The food systems is responsible for about 1/5, transportation sector about 1/6, and heating and cooling less than 1/10. But what is so cool about this chart is that renewable energy can be the solution to more than 4/5 of these emissions. So by electrifying heating and cooling, the bulk of transportation, and a portion of manufacturing, and then by transitioning the remaining thermal manufacturing and long-haul transportation sectors to green fuels, generated with renewable energy, solar, wind, and batteries, we can take care of most of these emissions. So while it's only 27% of the problem, the electricity sector, the electricity sector can be 4/5 of the solution. So that's pretty exciting. One thing that's not exactly reflected here right now, which is a new, very high-profile energy-hungry sector that has been gaining a lot of attention right now, is generative AI data centers. The estimates for how much these AI data centers are going to increase our total electricity use in the US are all over the map, but they range from about a 1% increase to somewhere in the low double digits. The AI race is certainly on, and it's anyone's guess who will win it and how much electricity we're going to need to power it. But what these hyperscaler companies building data centers are looking for, to actually my great surprise, is not primarily or just only cheap electricity, but fast electricity, like bulk electricity. So in places like Texas, surprisingly enough, the fastest electricity around is renewable energy, large-scale wind and solar, where you can plan and build big projects in about 3 years. But in California, we not only have expensive electricity, but a heavily regulated process that makes developing new large-scale solar and battery projects pretty slow to come online. So these hyperscalers have shown little interest in building these data centers in California to date. And Fred did mention that Intersect Power recently signed a deal with Google to work with them to build some data centers. And you can see the press release on our website, and I can't say much about that right now, but you can see what is public on our website. So it's pretty interesting, exciting times. So related to how things work in California and how slow they can sometimes be, I've been recently really excited to read the book Abundance, which was published a couple months ago by Ezra Klein and Derek Thompson, because suddenly what I do, environmental permitting, was cool for the first time ever. In my career, everyone involved in public policy in California and elsewhere is talking about my job. If you haven't read it, the central thesis of the book is that we've forgotten how to build things. We've adopted public policies that in many cases have protected communities and the environment and public health, or they try their best to do so. But as we have adopted these public policies, we've often prioritized process over outcomes. So what this has done is resulted in our ability to, it's reduced our ability to get good, clean, beneficial projects like affordable housing, for example, and clean energy across the finish line. In California, we have, for example, the California Environmental Quality Act, or CEQA, which has been really important because it requires a transparent process for discretionary decisions by public agencies. It includes public participation by community members, and it requires smart environmental decisions to be made. But what ultimately fails with CEQA, unfortunately, is its tendency to result in litigation and sort of hostage holding of large projects by special interests. Unfortunately, the state legislature has been pretty allergic over the decades to anything that smells like CEQA reform, but I truly think that some smart reforms on CEQA and other state policies are going to be required to enable our ambitious energy transition that we've set for ourselves in other public policies, right? It's not just the goal, but it's enabling the pathway to get there. So Texas is still kicking California's butt in terms of scaling up and building utility scale renewable energy. A couple of other things that I'll note here. I've seen a sharp rise in community rejection and opposition to large-scale solar, in particular in California, over my career. And I've been working in large-scale solar and wind and battery storage development for about 15, 16, maybe more years in California now. One big reason that I see for this is the rise in misinformation and disinformation about the impacts of renewables, but I'm not going to talk much more about that. But also in California, another one of the big reasons for the rise in community rejection, I believe, is that the industry has enjoyed what was an important subsidy in its infancy in California, which was the solar property tax exclusion. What this did is exempted the solar equipment and other improvements from being taxed by counties, resulting in very little direct revenue to local governments and therefore little economic development opportunities for rural communities that host these facilities. But I am happy to say that this exemption is expiring. And so all utility scale solar projects that come online after 2026 will pay full freight property taxes, which will substantially boost annual revenues of rural community governments as these projects come online. For example, a project I'm working on right now in Fresno County, the project is quite a big one. And we have determined that we will be the second largest property taxpayer in the county. In the entire county, just the project alone will be the second largest property taxpayer when the project comes online. So that's pretty exciting. I think it's important to note that this property tax exclusion sunsetting will be an enormous economic development opportunity for rural communities over the next 20 years as we strive for a net zero grid. And that's mostly what I had to say today. And so in closing, I'll just offer that we have a lot of potential here in California to get things right and honestly show the other 49 states and the rest of the world that a high functioning zero carbon economy is possible. We have the zero carbon mandate. We just need to enable the execution of this incredibly ambitious project. And we have to get it right. We have to show everyone we can do it. We have the right economic incentives for rural communities. We just need to collectively figure out how communities can best take advantage of those economic development opportunities. Working together and crafting smart public policy locally and statewide, and beyond just the standards, the renewable portfolio standards and targets, will be critical to enabling the transition. Thanks so much.
Texas kicking California's butt, hey? Well, let's see if we can do something about that.
Indeed.
Next up, we have a representative from the community solar development angle. Jocelyn Fairbairn is VP of Corporate Development for Luminia, a company that, amongst others, has a focus on community solar. She's been involved with energy storage, solar financing, residential construction. Please welcome Jocelyn.
Thank you, Fred. Thank you for having me, and thank you to all the other presenters. It's really exciting to see what everybody's doing, and especially to Alfredo and Charles, who did all the hard work, and Joel for explaining community solar. I think that Alfredo said it perfectly when he says it's an easy concept, but it's hard to implement. And I think that that's something that I'm going to be speaking to a little bit today. Community solar is really exciting because it can bring a lot of opportunities to a lot of different stakeholders. And in California, as Charles alluded to, we've been having a harder time scaling it than what we've seen in other states. So what I want to talk about today is, what Luminia is doing in order to continue bringing community solar in. The types of projects that we're doing, we're very focused on California. In fact, I would say we're doing a hyper-local approach, and we're starting in our headquarters and hometown in San Diego. So I'll be talking a lot about that. And then I just want to talk a little bit about community solar and some of the issues that we're facing as we're moving forward. So I'm going to try to share my screen here. Bear with me. Are we seeing a slide? All right. So Luminia, who we are, what we do, our headquarters is in San Diego. We have about 15 full-time employees here, and then a couple throughout California, Canada, Arizona, and nationally. We've got over 100 megawatts of commercial and community solar in development or in operation. And we're really focused right now on making local impact. You'll see that the picture I'm showing is for one of our most recent projects that we contracted with a local community choice aggregator, Clean Energy Alliance, also known as CEA. We have 40 megawatts of solar projects, located on rooftops, and then 20 megawatts of storage projects located on the built environment. So as Fred alluded to, we do community solar. We focus on working with CCAs. I'll talk through the different ways we are trying to implement community solar, but we're also very much focused on the built environment and commercial and industrial projects. So I'll walk through the different types of projects that we're looking at here. But one of the biggest things for us is that we focus within the community so that we can bring all of the benefits of these renewable energy projects to the communities that they're located within. And I just wanted to speak a little bit to the types of projects that we're doing. You can see this project that I'm showing here on my screen is actually located on a school. The majority of our projects are located on rooftops. We also have projects located on ground mounts as well. However, it really depends. If we have it on the rooftop, there's 3 different ways that these electrons go into the community. So this project that I'm showing right here is the Carondelet High School. It's a private high school located up in Northern California, Walnut Creek area. And this is a behind the meter project. So the consumer is actually receiving all the benefits of the solar that's on the roof. So they're reducing their load and receiving energy savings. We also have community solar projects. We have a 2.2 megawatt project that we were able to contract with San Diego Community Power, which is another local CCA in San Diego. And I'll talk a little bit about that existing program in a moment. The way that program works is that we locate the solar on the rooftop of our host facility, which in this case is a mall, as well as a carport. And then those electrons flow to the load serving entity through a program called DAC-GT, and low income residents receive a 20% bill on their savings. So that's implemented through load serving entities, and I'll talk through that as well. And then the last is what we call front of the meter. And that's where we locate the solar on the top of the roof. But that actually goes to the CCAs or IOUs, community choice aggregators, or, PG&E, SCE, SDG&E, those who are actually generating and procuring that electricity, and then they provide it to their community. And the reason that we like working within our local community is that we can bring the rent revenue. So we'll actually lease these rooftops in the areas that we're locating the equipment. We use local labor. So we're working with contractors, installers, developers, even vendors that are working in our local communities. And then we're offsetting the emissions. For us, we think that building to the load, where there's load makes a lot of sense. It helps bring resilience to the distribution lines. And we really feel like along with utility scale solar, residential solar, behind the meter solar, it's an all-in approach, right? So this is where we really like to focus. There's a few ways that we are going we're able to work through community solar opportunities. I think Charles did a great job explaining kind of some of the issues that we are seeing with the proposed California program right now. So we appreciate all the work that Chris Ward is doing. I'm actually a constituent, so it means a great deal to us, all the work that's been going on to really create a robust program. In California, unfortunately, we've just been slow to start. So we're finding creative ways to continue to make that moving forward. So there's really 3 ways that we're tackling this. One is through the existing California DAC-GT program. Throughout the legislation that Chris Ward put together, we were able to make some changes to the DAC-GT program that actually made it really a little bit more available and easy for us to work with it. There are some pros and cons that I'll walk through. Another thing that I think is really important, and I just came back from a conference with Cal CCA. Community choice aggregators are really doing a lot of great work, doing local procurement, doing innovative programs like virtual power plants, and then working with their local developers and ratepayers to come up with programs that can bring local energy to their communities. There are 25 different CCAs in California, and that brings a little bit of complication because they all have different requirements and needs, but the fact that they're all working towards finding the best value for their community is really important. And then, of course, there's developing programs as well. So we can't thank Chris Ward and his team enough for what they're trying to do to become get this program moving. But it is a complicated process, and it is, once again, hard to implement. But with the California DAC GT program, there was roughly, I believe, 160 megawatts that have been implemented, and there's an additional 144 megawatts that is going to be available for people to submit proposals into programs. There's some pros and then there's some cons. So one thing is that the program is available. You can work into it right now. The other thing that makes this a little bit easier than other programs that we have is that the load serving entities are handling subscriptions and make sure, at least in the programs that we've worked in, and it can change a little bit, that those low income ratepayers are actually receiving the benefits and getting that 20% discount. So that meaningful ratepayer savings is great. The other thing that was a bit that's great now is that they've modified the rules of the program. The projects needed to be within a designated DAC census tract in California. In San Diego, that was relatively limiting. Just to give an idea, we had multiple census tracts. But if you looked at the rooftops that were available that could house the appropriate size system, we were around 750. But then you just went to that census tract, it brought it down to about 10% of the available rooftop TAM, so total addressable market. So from my perspective, now that they've made it that the project can be within 5 miles of that community, I think that it still serves the community, but also makes it more available. Some of the issues with this program and the rollout is that it's fragmented. So every one of the load serving entities that have some kind of capacity for this program are implementing it. So what that means is that there's slightly different rules, there's slightly different timing, there's slightly different requirements for what type of projects they're looking for. So that creates additional complication. And then also the schedule for which they announce RFPs is different. Some people do it, they're mandated to release RFPs for people to provide proposals at least once a year. And so you're not sure when that's going to be. And you have to have your projects ready to move forward. So that causes some complications for developers. This project is competitive, and it's also not going to be extended any further than it already was. The 144 megawatts that are available now was increased based on the CPUC proceeding. The projects are expensive. They're located in areas. We're adding prevailing wage. These are all great things for the community, but with the economies of scale and the size of these projects, they sometimes can be more challenging. And then with the RFP process and then the development and interconnection, these projects can take a long time, especially with what's going on with all the different intricacies. Sometimes it can be a challenge to and take over a year to get these done. Last thing I just wanted to talk about are just some of the California community solar challenges we have outside the programmatic issue of having a project or a program that will really let us accelerate it, like other states, for example, like New York, who got a gigawatt in the first couple of years that it was open. One of the things, and it was talked about by multiple different parties, is interconnection. The grid is becoming more and more constrained. We are a leader in renewable energy, which means that comes with a more constrained grid, makes it harder to find locations where you can site projects even on the distribution grid. Sometimes upgrades can make that cost prohibitive. And then, of course, you're always running through timing. A lot of these projects are distribution based, which means that they can go through a process that is called a fast track through the different utilities. That's really great, but it really limits you to 3 to 5 megawatts depending on the location that you're working in. And sometimes that conflicts with the economies of scale that you're looking for. And then I think the next thing that I just wanted to touch on is that in California, no matter what, we need storage to be attached to every project. And that adds complications that a lot of other markets don't have to work with. So that limits where siting is. There's two separate things. One is, where is the good location for storage? Sometimes also the best rooftop site is not the best storage site. So that can limit your locations as well, especially with our company who's working on the built environment. And you want to make sure that it's valued properly within our market, which can be complicated. And then the last thing that I feel like I'm echoing a couple of our speakers, but I think it's important to discuss, is just consistency. When we have delays in getting programs created or implemented, it just creates uncertainty within the market, which increases prices, unfortunately. There's been a lot of changes, especially as it relates to storage, on what's approved and what's not, where what's needed. There are some great regulations and standards that were put into place, and just making sure that all of our different jurisdictions have access to that, as well as our fire departments understanding and getting the training on how best to work with it. And lastly, supply chain tariffs and uncertainties with the IRA can cause some concerns as well. But what I do like is that in California, there are a lot of different entities working together to try to make this work so we can bring the most value to our communities, and drive a lot of local impact. So thanks, Fred, for the time to share what we're trying to work on.
Certainly. It does seem to me that the regulatory environment could be simplified somehow. And so I think one of the things that would be nice to see is a friendlier regulatory environment for community solar. All right, moving along, then our next presenter is Scott Murdishaw from the California Energy Storage Association. He's their executive director. His broad understanding of the energy storage industry makes him an ideal panelist for the all-in approach. Please welcome Scott.
Hi, Fred, and thank you very much for the invitation to participate in today's event. I'm just going to jump right into it. Let me make sure everybody's seeing my screen. Is that working? Just 1 second there.
Okay, there we go.
Yeah. Okay. So as Fred said, I'm the executive director of the California Energy Storage Alliance. I have worked in a couple of other trade associations, though, including CALSA. You'll hear from Brad Hevner next. So I've worked on solar and storage policy at a variety of scales, and worked on policy related to other renewables, But I have to say, energy storage has been particularly challenging in the last couple of years. So let me go ahead and move into just what we're seeing in terms of the growth of energy storage in California, the value that energy storage provides to the grid in a couple of different ways, and then some of the headwinds that we're facing, particularly regarding safety and perceptions of safety. I won't plan on going into it in the presentation, but of course also federal policy regarding tariffs and Inflation Reduction Act credits, and whether we can continue to count on the availability of those tax incentives are also making it very difficult for developers to plan projects now and negotiate contracts. So just a little bit about CISA. We were founded in 2009, really at the very beginnings of the energy storage industry, before there was much of an industry to speak of. We're a nonprofit trade association, and we advocate for energy storage as a key resource to achieve a more affordable, efficient, reliable, safe, and sustainable electric power system. We believe strongly energy storage helps to achieve all of those goals. We have about 80 members now. That consists primarily of manufacturers and developers of energy projects. Many of those developers also develop solar, wind, and other renewables, and develop storage hybrid configurations with other renewable resources. We also have members who are energy safety experts and some law firms with specialization in the energy sector. And we represent both in front of the meter or utility scale storage and behind the meter storage. And we have several members who are developing alternatives to lithium ion technology. So while about 99% of the capacity in California is lithium ion, and it is the dominant resource currently, we have several members who are developing flow batteries, compressed air energy storage, and other approaches. All right, so this chart is the annual capacity additions of energy storage in California by year. And you can see that 10 years ago, energy storage barely existed. This is, it's in some ways hard to believe, but as much as energy storage has really taken off as a mainstream resource in the energy mix in California and in other jurisdictions of the world, the industry is still relatively in its infancy. Even a decade ago, there was scarcely any energy storage, either customer-sided or utility scale serving the grid. You can see in the first few years, things moved along fairly slowly. One of the programs I worked on when I was at the CPUC was the Self-Generation Incentive Program. And you saw that a lot of the early additions of energy storage were customer-sided, so residential and some commercial. Starting in 2020 to 2021, utility scale energy storage really began to take off, especially with some decisions by the CPUC that required utilities and community choice programs to begin procuring a lot of additional capacity for reliability. So those are the annual additions. 2024 is only through September, so that number is actually larger for the end of the year. I kind of stopped it there because that's where the Energy Commission's official semi-annual survey of energy storage ends. It should be updated any day now. So I'm very curious to see how much additional capacity has been added in the last 6 months or so. But the total, we stand at about 13,400 megawatts by September of last year. Most of that was utility scale, about 11,500 megawatts. And you can see residential and commercial rounding out. What is the value that energy storage provides? There are two ways of thinking about it. One is the environmental value. It is absolutely a cornerstone resource for achieving the state's greenhouse gas emissions goals and reducing greenhouse gases in the electricity sector. So I thought it would be interesting to pull up a couple of charts from the Independent Operator website. So this is April 29th, 4 years apart, 2021 and 2025. And it may be a little hard to see the numbers, but I think it's really just the trends that's the important point that I want to communicate here. So I removed a bunch of the resources to make it easier to see. So you can see those are kind of X'd out around the bottom. What you see here is total renewables in green, natural gas generation in the kind of reddish brown, and then batteries in blue. And in 2021, that the charging and discharging is kind of hovering around zero because there wasn't a lot of storage, a few hundred megawatts operating at utility scale at that time. And the role that it was serving was to provide short-term reliability. It was charging and discharging throughout the day to help balance the frequency on the grid. So it's not having much of an impact in terms of actually absorbing the huge influx of renewable energy from solar during the middle of the day. And it's not having much of an impact on the way natural gas-fired power plants are used. In 2021, natural gas-fired power plants were starting the day at about 9,000 megawatts of generation. As solar ramps up, the natural gas dips down to about 5,000. And then there's this duck curve problem that the CRESO has been talking about for years, which is that natural gas plants have to quickly ramp up. So you see them ramping up from about 5,000 megawatts to over 13,000 megawatts of generation over the course of hours as the solar generation begins to decline towards the end of the day. If you look to the right, in 2025, that chart is completely different. The scale isn't quite the same because we've added even more renewables. So it tops out at about 23,000 megawatts. But you see that there's, with thousands of megawatts, over 10,000 megawatts of energy storage on the grid at that time, that it's playing a very different role. It's absorbing a lot of the solar energy that's being generated in the middle of the day. And then it's discharging that energy later in the day. As the sun starts to go down, the storage is providing the main reliability benefit of ramping up to replace the solar energy that's declining. And the impact on the natural gas power plants in California is enormous. They start the day at about 5,000 megawatts of generation, and then it stays much more level throughout the day because the energy storage is providing the ramping. That has the benefit of reducing the total amount of natural gas generation, the total amount of greenhouse gases and other pollutants emitted, but also those gas-fired power plants are being operated more efficiently because they're not ramping up and down as much. They're operating at a steadier state. Let me move on to the reliability value. This is a kind of simplified way of thinking about it. There are other factors at play, but I picked 3 years, 2020, 2022, and 2024. And I just show what was the peak load in the independent system operator area of California that year. How many blackouts did we experience, and how many flex alerts? So these are alerts that the independent system operator and utilities issue, calling on customers to reduce energy consumption in order to maintain reliability of the grid. So in 2020, I'm sure everyone remembers, we had a couple of blackouts. They were fairly short, but still, it was very touch and go for the grid for several days in 2020. And we only had 760 megawatts of storage. That's total, because behind the meter also helps support reliability by providing additional capacity to customers later in the day. In 2022, we had our all-time peak load. We had no blackouts, but by the skin of our teeth, 11 flex alerts and only 3,500 megawatts of energy. But by 2024, the picture is completely different. 2024 was actually our hottest summer on average in recorded history, but we didn't have as hot a day as we had in 2022. Peak load was lower. We had no blackouts, of course, and no flex load. So that's the value that energy storage provides. It has absolutely been a central resource in maintaining the reliability of the California grid. So about energy storage safety, I know this is a hot topic. We've been working on this a lot over the past few months. But energy storage technologies and the standards that govern the manufacture and installation of energy storage products and facilities, have evolved significantly in the past few years. The very first national standard for energy storage projects was published in 2020, and we're now on our second revision that's about to be finalized later this summer. And the California Building Standards Commission is adopting new standards for energy storage also this summer. About 95% of the existing utility scale energy storage facilities in California they use modular containerized systems rather than being built in buildings. You install several tens to hundreds of megawatt hours of energy storage in a building, kind of a warehouse type arrangement. And the benefit of these containerized approaches is that they limit the scale of the fire if they do occur to less than 1% of the capacity that we saw. So a typical container might have 4 or 5 megawatt hours of capacity. Buildings could have over 1,000, like Moss Landing has had 1,200 megawatt hours of battery in the building. We've also learned from these incidents that analysis of air, water, and soil samples that were taken during and after these incidents, both in California and New York, have never found any levels of contamination that were above public thresholds. And that's true at Moss Landing, which was the largest energy storage fire in the United States and most likely in the world, and it's certainly true at the other facilities in the containerized approach. There's our website with safety resources for additional information. And just to give you a picture, though, just to understand the difference between the building-based systems and these are both taken from Moss Landing. They're just two different phases of the Moss Landing project. So one, this is the picture of the facility that experienced the fire on January 16th. And on the right, you see the containers and how even if you do have a fire in one container, it's virtually impossible to spread to significantly limit the scale of the incident should it. And that's all I have.
Thank you, Scott. You know, I guess one of the reasons that we wanted to have you on was because of the importance of the understanding that we can't just be setting up solar without energy storage. We can't be doing renewables without energy storage. We need solid power. And so, do you have a comment on energy storage technologies that are coming? What do you see as the most promising technologies?
Well, at this point, lithium ion is by far the dominant type of energy storage technology. It accounts for the vast majority of energy storage, other than pumped hydro, which is a very old technology, but it's geographically constrained.
Yep.
But we have several members who have either pilots or their first one or two commercial projects that are now underway, and it really runs the gamut. So you have compressed air energy storage. You have a company that uses carbon dioxide. We have essentially like a gigantic tent that stores carbon dioxide, and they then compress it because there are some physical advantages to using carbon dioxide rather than air. Then it re-expands to produce energy. And then several different variants of chemical energy storage. Some of those are flow batteries that use either organic compounds that use vanadium or other chemistries. And some of those are static electrolytes. So they're not flow batteries. They're just not lithium ion. So they might use zinc or iron or sodium as an alternative, chemical for storing the energy. And at this point, I can't really pick a winner. They're all moving along with different grants or pilot projects. So I too am curious to see, 20 years from now, what will be the mix of lithium and non-lithium.
Okay, thank you for that. Very interesting. And finally, we have Brad Heavner, the newly minted executive director of CALSA, the California Solar and Energy Storage Association, where he has worked since 2013. Brad has more than 25 years of experience in renewable energy efficiency, low emission vehicles, greenhouse gas regulatory activities, and initiatives related to the grid. Here he cleans up last in the batting order with a focus on enhancing California's solar and storage programs for the state and for industry. I guess one of the things that I'm particularly interested in hearing is how we can protect the existing programs in this new environment. So please take it away, Brad.
Yeah, thanks, Fred. Thanks, everybody. Great to see you here. Thanks for the invite. And I noticed, Fred, that was the title of the talk that you asked me to present, protecting the existing solar and storage program. So I want to talk a little bit about the economic debate that has been raging for far too long that we want to put to rest. I don't want to spend the whole time on that, but we continue to be under attack by utilities who unfortunately see us as competition and throw bad policy proposals at us on bad economic theory. So we can talk a little bit about that, and then also I want to spend a few minutes talking about virtual power plants. I did prepare a few slides, so let me bring those up. Okay, so yeah, Brad Hebner, Executive Director at CalSA. For the previous 11 years, a policy director here at CalSA. So I moved over, I guess, I don't know, 6 weeks ago. CalSA is a trade group that represents behind the meter solar and storage, residential, commercial, industrial, agricultural, anything behind the meter. Solar and storage. We represent 680 different companies that have some role in solar and storage in California. So I have here a set of slides that we've been presenting to a lot of people, and I'm not going to cover all of them. They'll be here with the leave behinds that you can look at later if you're interested. But a couple just to highlight. First off, where we're at in the market. And you can see, obviously, we know that there was a great surge of customers that signed contracts to install solar right before the transition from NEM 2 to NEM 3. And then we installed those over the following year. But in terms of new business under NBT, net billing tariff, or NEM 3, we knew it was going to be tight for the first few months, but nobody expected that 2 years later we would not have rebounded. So we're obviously working at it, but we're half of where we believe we should be right now in terms of market volume, and hopefully we can see that growth sometime very soon. We've seen bankruptcies and a lot of layoffs and difficult times. A lot of the companies have stabilized now. A lot of the companies will tell you, yeah, well, I laid off half my staff, but at this point I'm stable and hopefully we'll grow from here. That's kind of the state of things on customer solar in California. And then, a lot of it happened, the transition to net billing was directionally the right thing to do. It happened too far, too fast. But that's where we are. It's self-consumption is our world. Everything needs a battery, and customers should be using their own generation for on-site load, even in non-solar hours. And we can do that. So what we want is to focus on virtual power plants from here. Let's optimize the usage of those customer batteries for the grid. We're happy to be responsive to signals, and that's really what I feel like I should be spending most of my time talking about. Unfortunately, we're still defending the legacy net metering customers and other things that get thrown out in sort of yesterday's frame of mind. So I wanted to talk a little bit, just so you guys had it, because the cost shift debate has underlined so many different policy debates here in California, and sadly continues to. I was hoping after NEM 3 that would sort of die down, and the utilities have even ramped up their pressure on this cost shift concept. So just so you guys have it, I want to give quick highlights of some of the research we've done to counter the utility methodology. And first off, it's all based on the concept of departing load. Utilities like to say that all of their costs are fixed, and when solar customers generate their own power, it leaves others to pick up a bigger part of the pie. But in reality, we have increased our usage, basically in line with that dotted red line, the CEC forecast. But what the grid has seen has remained flat, remarkably. And that has a lot to do with the solar that has come online to offset the generation and offset the amount that we need from the grid. So we are not departing load. We have kept usage from the grid from growing. And a lot of that, what matters a lot is in the middle of the day, the annual peak. We build the grid for the annual peak, right? You need to have the grid that's big enough to deliver the most we're ever going to need. That still happens in midday and during sunlight hours on hot summer days. This is our peak day in 2024. And you can see, we never see that dotted or the striped section on top. Everything in solid line here is CAISO data. And then I added just, a standard PV profile to all the solar that we have to add the thing on top, which shows our actual consumption, right? That lighter red line is how much electricity we actually use. It peaks in the middle of the day, in the daytime on a hot summer day, which is also when solar is generating near its peak output. So we need to build less grid because of that rooftop solar. Now, if we were to continue to build solar only without batteries, it would become a problem. We needed to transition to a tariff that pushed everyone to have batteries, and we've done that, right? Because we need to solve the net peak at this point going forward with new resources. Doesn't mean the existing solar systems don't continue to provide value, knocking down the true peak that we build the grid for. And then looking forward, as we do actually greatly increase our energy consumption from electric vehicles, heat pumps, and other electrification, we're going to need a lot more power. And even if we grow a lot with customer solar, that yellow there is growing 25% year over year between now and 2030, which we're not going to grow 25% every year over year. It's impossible to sustain that. But even if we grew that much, we would only be offsetting a little more than half of the new consumption. This is CEC forecast based only on heat pumps and EVs, not even data centers and other things. So the concept of departing load, looking at this picture, is complete nonsense. We need to keep our consumption from growing, our grid consumption from growing. In any scenario, we're going to need more power lines and centralized power plants. But if that's our only solution, it would be the wrong way to go with our policy. And then, even after installing solar, NEM customers pay substantial bills, an average of $105 per month, and the utility methodology on cost shift ignores the amount that customers pay, and you really can't answer the question of whether the important real question: do solar customers pay their fair share for the grid after installing solar? And how can you answer that question if you don't look at what solar customers actually pay? And when we look at the average of $105 and take out the variable costs that are associated with increased utility costs from the net usage, you're still left with $70 per month that solar customers pay towards fixed charges. They pay more than their fair share. So we're not saying this to undo NEM3 by any means, but we do want to stop this conversation about the cost shift and move forward and talk about the policies that will really help us going forward. And so a couple other slides related to cost shift that you can look at in our bottom line, is simply, let's, number 4, demand side grid support. Let's talk about that. And the other thing, just remove barriers and stop harassing NEM1, NEM2. So that's where we're at. Let's talk just a little bit about virtual power plants. I think Yang Yu was talking a bit about DSGS. This is one form of the virtual power plant that has been growing here in California. There's huge growth last year, and we don't know who's going to enroll in 2025. The program year started yesterday, May 1st. What day is it? So we're now in the new program year, and we'll see what the enrollment is like. Just based on anecdotal talking to some battery aggregators, I know that there are intentions to enroll even more capacity this year than last year. So it's very good to see it growing. The battery aggregators are seeing enough value here to do the hard work of enrolling customers and managing systems and setting up their whole systems to interact with DSGS. Last year, we still don't have the full program evaluation, but anecdotally, we heard that the response was good. That the evaluation is that people showed up when they were supposed to. And so if we can grow and continue that happening, it's fantastic. This is, in my mind, very good proving ground that distributed batteries can be operated in a fleet in a way that is reliable and provides good value. So we need to grow from here into much more than this emergency response program with outside funding, but it is a good program that gets us by for now. We have an unknown amount of money available. We know that there's $52 million that was in the program last year. There is an appropriation in the budget for $75 million and a previous year appropriation of another $75 million that can be used either for DSGS or DEBA, basically, or maybe other programs. We are expecting that. We're hoping and expecting that the Energy Commission to choose to leave that money in DSGS. So both of those 75s are real. And so we could have up to $250 million available in the program. Somewhere between 52 million and $250 million is what's in the program. And the thing we want most is long-term stability, because we're asking a lot of companies to, set up systems to interact with this program and to sell it, to bring it to customers, enroll people, and have it be a big part of their businesses. So it takes a big commitment from companies to jump in and build that. And some of them are doing it in hopes of long-term funding, and some of them are waiting because they would do it even more if there were more guarantee for long-term funding. So we do appreciate. There was a question earlier, I think, about the commitment from the state and who is committed to putting money into this program. I don't know if the question was particular to this program, but the fact that there was the $75 million in this current year budget, adding to it when it wasn't down to zero yet, did show some commitment from the Newsom administration towards this program. It was a very positive sign for us that this, there are some negative signs out there about commitment to using DERs, but this is one that was standing out as the Newsom administration clearly saying, we think this works, we want it to continue, and we're going to put more money in. We don't know if that allocation is going to survive to the end of the legislative process this year, but it is in the budget. And then just looking at last year, this shows you when the events were called 16 times per year. And the way the program works is we get paid to commit the capacity, no matter how many times it gets called, that we're paid to participate. And but then every time you get called, you absolutely have to act. And so they did call us 16 times, and we did discharge our batteries to avoid supply constraints. And that's it. Those are the slides I have. The last comment I'll make is, we don't love it that the main program is one that relies on outside funding, that we would like to be in the market, right? And we really want to build, and Yang touched on this as well, that there are discussions underway at CalISO, and they're long-term, but it's encouraging that some real things are on the table about giving better value to behind-the-meter exports. The biggest problem we've had is that CAISO hasn't been willing to recognize exports from customer-setted batteries, which is a little perplexing to me in one sense, because to them, it's all load reduction on the circuit. The view from CAISO is one customer discharges batteries into the local circuit. It's really load reduction in CAISO's viewpoint, as long as you don't backfeed on the circuit, which is rarely done for interconnection reasons. And then they're also concerned about deliverability. There may be customers near this battery, behind the meter battery, whose load is basically dependent on for some wholesale generator. The wholesale generators need to have deliverability. They need to have a guarantee that someone that the power flows to will need that power. And so CAISO has said historically, it's hard for us to even study that when there's all these small systems all over the place, when we might be relying on the load on that circuit to be used by the large scale, to soak up the energy from large scale generators. In the era of, so I recognize it's a challenge, but we just need to figure that out, because there's a ton of potential here. We have a huge fleet of batteries that's expanding every day, and we need to put them to use. And I would argue that figuring out this challenging puzzle is easier now that we are increasing our load with electrification. We need more power everywhere at this point, so it should be easier to say, hey, there's going to be load where it's needed, and the wholesale resources will continually to be valuable as we have increasing reliance on local resources.
Mm-hmm.
That's the end of my talk. Happy to chat more about any of that.
Okay, thanks, Brad, very much. questions from the panel to other panelists? Okay. I have a couple of questions. One for V. John. John, we've seen really steep increases in electricity prices over the last few years. What do you see coming?
Well, first of all, I think the upward pressure on rates is coming principally from wildfire costs as well as resource adequacy or reliability costs. On the other hand, it's why there is so much sensitivity around cost shifts and value that's created. I think, there's tension, as has been noted, about, people wanting to still go back and renegotiate NEM 2 and 3 either way, as well as take people off the 20-year grandfather. I don't think that's going to happen because of the fairness and equity involved. But I do think that we're going to have to be careful as we seek to expand community solar and distributed energy resources and storage, that we're going to have affordability be part of that conversation. I also think the issue of battery safety and standard setting is a significant issue, not just for small and large-scale battery storage used on the grid, but also with electric vehicles. The damage caused by the fires and the hazardous waste issues that have arisen have highlighted that. And then the Moss Landing fire, while it's not representative of the industry, because the technology was and the operator were both not state of the art, there nonetheless, I think, is a need for the Energy Commission to adopt standards so that we can maximize, because as Scott said, that batteries are essential for both reducing the cost of resource adequacy as well as to provide local capacity and reliability. And yet we've got to be able to cite these projects with confidence. And I think the danger of the Moss Landing fire is that it's going to lead to some overreaction and local opposition to citing projects. That's going to have to be something we write out. But I also think that we can create public confidence if people understand that we are prepared, not just first responder training, but also with a diverse portfolio of resources that can contribute to affordability.
So, John, do you think that there is a different way that we could fund the extreme cost of wildfires?
Well, I think the liability issues are part of the problem because it raises the cost of borrowing for the utilities. PG&E went into bankruptcy and they're still not fully recovered. So it affects the ability to, pay for everything. I think we're going to have to manage all of this with a clear eye and good data. And everybody sort of looks at data through the lens of their own interests. But I think that we've got the capabilities that it's like we need to I think the analogy I've used before is we need to turn a garage band into a symphony orchestra and see that everything works together and comes together, and that people, I think the other thing is everybody has to become a good citizen of the grid and recognize and be honest about what costs they impose as well as what savings and benefits they provide.
Mm-hmm. Okay. Well, thank you very much for that. Alfredo, do you have any closing comments? It looks as though we're just about done.
Yeah, I believe there's still one answer left open. And this is to Yang, if he's still, oh no, he already left.
He left.
So, yeah, okay. No, no, just I think you know, with community solar being a challenging you know, approach to continue support the development of solar in the state, there does come a lot of opportunity, right? And so I think groups like Solar Valley, it's open to collaborating even beyond those who participated in the panels, right? So the attendees, they should feel free to reach out to us, because our center is always working on applied research and interested in collaborating with different groups. So I just leave it as you know, an opportunity to collaborate. Yeah.
Good point. All right. Well, so if there is nothing further, it's about time to close off. If there are no further comments, speak up or forever hold your peace. Are we done?
Yes, I believe we are, Fred. Thank you
Okay.
everyone for participating, and yeah,
Thanks to all of the participants. It's been, I think, a really good show, and look forward to continuing these discussions with you. So many
Thanks, Fred.
thanks.
Thanks,
And
Ron.
please,
Thanks, Alfredo.
oh,
Thank you.
yeah,
Thank you all.
absolutely. Please send in your presentations to Alfredo or myself, and we'd like to make them available to the participants. Okay.
Okay. Take care, everyone.
Thank you all.
Thank you.
Thank you.
All right.
Goodbye.
Thanks.